red light going. Okay, well, hello everyone, welcome. My name is Carl Ott. I'm the current president of Dallas Personal Robotics Group. We're going to meet as we typically do every Tuesday night and just have a kind of virtual builders night virtual, since COVID's making it not so easy to meet in person. And the format's pretty straightforward. We just go around and people talk about the projects they've been working on, raise any questions, try and play Stump the Club. That's always fun. We've got a lot of great experience to share. I guess I will lead off tonight with just a little bit of background. We've had some questions about, if you're interested in joining the Dallas Personal Robotics Group, how could you do it? You don't have to be in Dallas. We're having a lot of interaction outside of Dallas. So, positive side effect of the COVID crisis. But to join DPRG is pretty straightforward. You go to our website, dprg.org, and then here under info, joining DPRG, and it brings up this page. And by the way, you can subscribe to our mailing list. You don't even need to be a member. Just get your email added in. I think we have some 3,000 people that are on that list. It's not a very spammy list. At least people haven't complained, and we get some interesting discussions there every now and then. You can subscribe for posts, and then to become a member, we do for members, full-on members, we ask $40 per year. And that helps us take care of some of the costs we have, like paying for meetup. We pay for physical rental space at the Dallas Makerspace. And you get just fabulous recognition on the website. But we're wide open and very inclusive, so it's not required to become a member. But going online, and there's the application. Any quick questions on that before we move on? I think it's pretty straightforward. And if you get stuck, just send an email to, well, I'll show you where to look. You can send an email to the DPRG list, or what you can see in here. Okay, sharing again. We have our contact list under the info page. Nope. We have general info. Oh boy, where did we put it? Here we go. Under info, general info, you can just mail any one of these, and sooner or later it'll find the right person and we can take care of it for you. All righty. So thank you guys for raising that question. That's something we've skipped for many meetings, and with so many out-of-towners, especially, and new people, it's helpful to bring it up. So with that,
Carl.
Yeah. Hey, Doug.
Go back to your screen. Do what you were doing, showing.
Okay, I'm trying to get.
If you're re-upping, all you have to do is go to the member tab. Okay. If you're re-upping, like Ray.
Yeah. For existing members.
Yeah, you should be able to just go to the member tab, and you can see it also has become a new member.
Oh, okay.
So you can look at that too. But go ahead and click that.
Okay, I've clicked it.
Okay, and then it just,
Same info.
if you hit the join online now, I think it takes you to the store. See the link, join, yeah, click on that.
Click that link.
Yeah, and there you go. And then this is just a WooCommerce store, very similar to what you'd find in a lot of websites. Okay, and you just add it to your cart, and then you say see cart, and then you check out.
Standard e-commerce. Yep.
Yeah, and then you would proceed to check out. Now we only take one. Right now we only take PayPal. If you have a credit card, you can still use PayPal, but you have to have a PayPal account now, or you can send money via snail mail. That's also possible. And the address, I believe, is listed there, if I remember right. Usually we, like I say, most of them you go by PayPal. I think I haven't had, there's only one person who pays by cash, and that's Will. So, so other than that, everybody pays PayPal.
And nobody yet who wants to pay by Bitcoin, but.
Well, I don't know what, now that's over what, $10,000? It might be kind of like.
Oh, no. It's fractions of a Bitcoin, but
Yeah.
last I checked, it was 24,000 per.
Yeah. Yeah, I don't have any, so I don't look at it. I did read a story about a young woman who said she kind of regrets using the 10 Bitcoin she did to get a Starbucks.
Yeah.
So anyway.
Yeah, I regret taking a payment for a job in $5,000 cash instead of 5,000 in Bitcoin 5 years ago, because that would have been pretty nice.
Yeah. Okay.
Yeah.
If anybody has any questions, they can just can send a message to either Carl or myself. I mean, I'm the secretary, so just secretary@dprg.org.
And so once we get joined up or whatever, you'll get our set up for our passwords to the member site and all that kind of stuff.
No, you do the password yourself.
Okay.
You're the only person who knows it. So the only way, like if you lose your password, I have to go in and assign you a temporary password, which you can then change. Okay. And like Ray, he's not getting the message. You should get the message. You might want to check spam just to be on the offside. But you should get a message that says, verily that you've asked to change your password. But I'm going to tell you that this is a WordPress site, and WordPress has gone through some real big upgrades lately, and things have kind of gone wobbly. So, you have to be a little patient with us, but we'll get it done. So,
I have a
anyway.
community service related question. Has anybody tried to get a COVID vaccine yet?
COVID vaccine. So I know some people who have.
Really?
Yeah. So apparently, just as an aside, here in Texas, obviously, if you're a frontline healthcare worker,
Right.
But there's a place. So several of the people in my extended family are in the healthcare industry, and one of them was just all over Facebook and networking and stuff, and they discovered a doctor's office like hours drive north, so almost Oklahoma, on 75, and they had 250 doses.
Wow.
And they were making it available to anybody who could prove they're in the healthcare industry or over 65.
Okay.
So she was in the healthcare industry, and her mom is getting past a really nasty bout of cancer treatment in the right age group. So they took her up to get the first dose.
Wow. So was that in like Grayson County or Fannin County?
Yeah, I think it was in that area. I forget the name of the city, but
yeah, I've called around. I'm over 60. I'm in the 1B group, so and I'd like to get one, but it seems like Brookshire's. There was on the news. There's I think it's called DFW or no NBC DFW.com. It's I think Channel 5. They published a thing saying people in the 1B group could start to get vaccines. So I started calling around, and nobody seems to have any vaccines. So, but I was just kind of curious if anybody else had success.
I'll ask my wife if she has the name of that place.
How do you know which group you're in?
Well, 1A is like, healthcare workers, first responders, I think even essential workers. So like if you're in,
Is there like a website or something where I can go click a few buttons and it says your aura is purple? Whatever.
yeah, I don't know. I think most of them have information about, the classifications. I know 1B, you have to be 65 or older. I think the next one, 1C, you can be between 16 and 64 and have, existing conditions that make you more susceptible to the virus.
Well, I think existing conditions is actually also 1B.
Yeah. It doesn't, you can just be over 65 though.
No, you don't have to be over 65 if you have a condition. So it's over 65 or a condition.
Okay, all right.
It looks like Kareem has a PDF posted from Texas government that might be helpful for this.
Yeah.
Thanks, Kareem.
Anyway, on that website,
Sure. My wife got the vaccine. She's a medical worker, but no, we don't know of anybody outside of that that's gotten the vaccine yet.
We're triaging to 65 and older with the condition that anybody 65 and older than.
Well, I am apparently in the 1B group.
Yeah, so am I.
Yep.
But I haven't gotten anything from Parkland yet about availability.
They're working on it. They're saying mid-January for like the highest risk Parkland patients. Again, they're trying to triage. As they did with Parkland employees, they did 65 and over who were face-to-face in COVID unit first, and then in primary care. I'm in primary care face-to-face with patients, but not in a COVID unit per se. I do see patients that are positive. And then they expanded to the rest of the staff, but they triaged it based on age and existing conditions.
Yeah.
So everybody in Parkland, if you work at Parkland, you can get one.
Even though I'm in the 1B group, I'm going to stick by my guns that I said earlier, that I'm not going to be on the front lines or first in line to get this first round of vaccine. I think I'll wait till the second or third round, just for me. That's I believe in vaccines. I'm not an anti-vaxxer, but I'm gonna let others go in front of me in that case.
I'll be your guinea pig if you like. I'll go first.
I feel relatively safe, and I try to be safe. I feel that I'm safe on all sorts of things. There's lots of other people that could probably use this, even though I do fit one of the 1B classifications. So, yeah. Actually, I'm probably in two of them. One because I'm fat, so I'm a fat ass. So there you go. I say that in all the jokingly. I'm not trying to self-deprecate. I was trying to be funny, right? I guess it's the definition of self-deprecating. Okay, never mind. I'll be quiet.
All right, and that's the cool part about our club. We take all kinds of questions, right? Any topic.
Unrelated, completely unrelated to all about it. Thank you.
So who would like to jump in and talk about the robot project? Any? Oh boy.
I can share some
Go for it.
Some information here.
Yeah.
So, I was still working on the hardware, wiring things up. One thing that I realized was, so I put two more motors in, and for some reason the two motors weren't driving well. So I had a different board, which has two LED with this basically the out one, out two. The LED, for some reason, both would light up. So what I found is when I drive, say, one is 8 volt, the other is 4 volt. So it cancels out a bit. And initially I changed, so, it's like, it's crazy. I changed board, I changed wire, and I think I've nailed down the reason. It's like the PWM, the signal I drive, those two wires. Actually, Doug, one time you mentioned I should use a higher frequency, which I changed and I didn't see any effect. But anyway, so what I found is the two PWM that has ECU has like 30 kilohertz, where the two that didn't have ECU is it's like 1 kilohertz or even 500 hertz frequency. So I mean, I don't really know why, but so far, like just before, like after dinner, I disabled the frequency change for those two lines, and it worked. It still, when I look at the two lines, it's like one is 1 or 2 volt, not 0, but the other is, I mean, it's better. So it's not like 8 volt versus 4 volt. I don't really understand why the motor drive board would behave like that. But yeah, so that's one thing. I don't know why, but so far it seems my drive is working. Yeah, but it's been a very hectic week because I had to basically switch out all the hardware I can think of before I realized, oh, it's not the motor drive board or it's not the wire. Yeah, that's one thing. Just want to share with you guys. I mean, if anybody can share some experience that make me understand what's happening, that would be
So Ray,
better.
Excuse me, Sean, what you should be, why you use the different PWM frequencies is to try to get the best match for your motor to make the curve as you increase the voltage, the motor speed increases linearly. Okay. And also to minimize the deadband around 0. Okay. Mm-hmm. So, depends on your motor, and you have to just, play around with it to find out which one. 30 kilohertz is not unusual for a PWM, but it is very unusual for one of these small motors and Arduino type circuits. In fact, I don't think I've heard of anybody really going that high. The reason why they like to go to 30 kilohertz is because for sure you can't hear it. And like a lot of our small robots, when you can actually hear the motors changing speed because they're humming at you. Because the PWM is, at 1K or 600 hertz or something like that. Okay.
Yeah, it's noisy. I realize that. The motor is noisy when it's.
Yeah. So if you have two, as Ray mentioned once before, the different pins on the Arduino have different default PWM frequencies. There's two that are odd. I can't remember which. I want to say 5 and 6, but I don't. Pins 5 and 6, but don't take me on it. Look up on the Arduino.
Yeah, I remember that.
Yeah. 5 and 6 is 980 hertz, and pins 2 through 13, 44 through 46 are 490 hertz. So it's about half.
Yeah, that's what I see. I'm using 4, 5, 6, 7. So I see 4 is 500.
Okay. And so one of the reasons, if I recall, and again, you haven't looked at Arduino stuff in a while. The reason why the frequencies on those two pins are used is because they're doing double duty. I think one of the timers is associated with them, and they're handling the delay function and something else. That's why they're different, if I remember right. But again, don't just view this as the clue, not necessarily as fact. Okay.
I agree.
Ray, you got it there. You might be able to give them a better answer.
One time, so we talked about it one time about the deadband, and you mentioned about increasing the frequency. So when I increased the pin, one of the pin, the clock just went crazy. So I didn't change that.
Well, if you look up change PWM frequency on Arduino, if you just Google that,
Yeah, I did that. Yeah, I
there's
did.
routines and everything, and you just select which one of the options you want, and you can change it. You just add the code, and it does.
Yeah, yeah.
You have to actually change some registers.
So the 30 kilohertz should work, right? Although it didn't. I mean, I think it's my problem is I mean, it worked for one of the motors before, but I mean, I don't know. I'm changing too many things. Maybe I'm adding another motor board, 2 motors, and now I'm thinking. So the behavior is I revert the PWM frequency increase. Actually, I didn't even check after I revert the code. So
Okay.
I just thought it worked, so I was.
Okay. I guess
So,
what I'm trying to tell you is that when you're adjusting them, and it's due to the inductance of the motor, and each type of motor is going to have a characteristic inductance that's going to be different from another motor. You can say, well, you can probably say that everybody who makes the 25 millimeter motors, they're going to all be roughly the same, but that's not even true, because some of them are going to have different voltages. Some of them are going to be wired for high power or low power. So you just have to, what you're wanting is that in a perfect DC motor, as you change the voltage, as you increase the voltage, the speed goes up linearly. And what happens with a lot of these small ones, you just get something like, kind of like this. I can't really do it.
Yeah, you mean the deadband. Right?
There's a deadband down here.
Yeah.
And then you're always going to have some deadband probably, but what will happen is you go up real quick, and then you kind of level off, or you go like this, where you have to be way up in voltage before you start seeing a response. Okay, and so that's why you want you have to do some testing. You have to put your motor out there and have your tachometer, and you go. Well, if you're doing low speeds, you can do it by watt counting, but usually I use that.
Vary that frequency and see which one has the best.
Well, no, what you do is you go like, okay, I'm at 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volts. What's the speed of the motor?
I measured those before. That's why I saw the deadband. So
it's not the deadband. It's the curve of the motor's response to the voltage.
Mm-hmm.
Okay.
Is there a reason? So when I look at when I was measuring the voltage, I checked, say, one of the channel, I have this enable, which is the PWM, and the A and B, like the two TTL signal. And then I look at the output, right? So the digital is
through, but I have come and went past it. There's 2 ways to power H-bridge. All right. And it depends on how many, otherwise it depends on how many PWM pins that you want to use. So like in your case where you're using an Arduino and you have a limited number of PWM pins, you probably want to use 1 PWM per motor. All right. Yeah. So there's three lines that go in. Yeah. And I want to say that oh God, Ray, help me out here. What are I don't have any of that documentation.
What's that?
There's the 3 input pins. There's an enable, and then there's 2 others.
Oh, sometimes there's like an A and a B input, the control direction, and then a PWM pin.
Yeah, so that's what it is. So you use the two A and B to change, not the outputs now, the inputs. You use that to select the direction and the braking. Otherwise, one of them will be a coast stop, and one of them will be a brake stop. Ideally, you want to use the brake stop.
I see. Maybe
Okay.
I mean this is I just assumed A and B is like, if A is high, for example, then that output A is enabled. B is high, then output B is enabled.
No,
And that voltage is
there's a truth table. You'll have to look in the, you have to look at the chip documentation and what are you, what type of chip are you using?
You mean the chip is that motor drive?
Can you show me your motor? Can you show me your motor? I mean your robot.
The motor drive, right?
But what we want to see is the motor controller. What is the motor controller?
You mean the Arduino?
Yeah, well, the motor controller, not, I'm sorry.
Well, this is
the motor driver. Excuse me, the motor driver, not the
I
micro.
have that. Yeah, I'll get it. I have that
Okay.
page. Yeah, back.
Okay, but anyway, that'll. Okay.
It's
Is that it?
Well,
package.
It's one of the label. Where does it say the chip?
The cheapest one is going to be something like the L192.
Oh, I see what you mean.
Well, I mean that's the one that has the big heat sink.
Yeah, it has a heat sink, I think.
Yeah.
Okay, I have it.
Okay, I'll tell you what. I'll they're in the club stuff.
Oh, yeah. L298 zero H bridge driver.
Okay. Anyway, L2. Okay. Yeah. Okay, and so that's pretty standard. That's a very standard chip. I mean, it's the most common, the most inexpensive, and you can find it on. We actually have a web page. Let me. I'm going to go offline for a second and maybe present something in a minute or two, Carl. Okay.
Sure. All right.
Yeah,
I just pulled up a
I'll wait
document for that. So it's one of these, right?
Yeah. Or
I was using. It's not exactly this one, but it looks similar.
No,
yeah.
As long as it uses that chip, right?
Yeah, L98. Yeah, L298. Exactly.
That's what matters because the chipset, the board is just how it connects up to the chip, but the chip has all the logic in there, right? And then this is what really then maybe Doug can find a schematic that shows the details, but this is what I mean. I just found this quickly, but it shows kind of what's going on, right? Because you got this N1 and N2, and I think those map to the AB, if I'm not mistaken. And what they do is it'd be easier with the schematic, but you can think of you got the motor terminal 1 high low and the motor terminal. Well, just think of a motor terminal 1 high and low, right?
Yeah.
So if you have one side tied to ground and one side tied high, and it's a brushed motor, it'll turn in one direction.
Exactly.
If you flip the high and low, then it's going to turn in the other direction.
Yeah.
If you tie them together, then it's going to short the coils out, and if you leave them both open, then it's not going to do anything. So what they're talking about here is that those A's and B's, they just say, well, on this pin, are we going to put it high or low? I think, or high or low. So basically, you can see here the truth table. So if they're both low, meaning ground, stop, don't turn. If they're both high, stop, don't turn. If one's low and one's high, then it goes clockwise. If one's high, if it's the other way around, it goes the anti-clockwise.
So I'm using the first three cases. I never used the 1 and 1 case.
Okay, so the 1 and 1 case, I think what those do is when they put them to the same, I guess whether it's high or low, then it shorts them out. So then when you try and turn the motor is trying to drive a dead short, which is more work, so it acts like a brake.
Okay. Now, I was wondering, how can this be? I know when I measure the digital input, it is indeed like 0 volt and 5 volt. How can that make the two output both have some voltage? So it's like, for example, I have the two input, say 1 and 0, right? I have a PWM of say 100. And then when I measure the two output, I mean, they both have some positive signal, and when it's effective, it's like one of the positive is like 1 volt or 2 volt. But when it's not good, it's like one is 4 volt, the other is 8 volt. So they're like fighting each other. But I did look at the digital input is correct. So I just don't understand how, what makes that happen.
It could be an issue with the part, or it could be an issue with the motor. What are you measuring that with? An oscilloscope or a voltmeter?
I used both. I mean, I have a meter, like a digital meter and oscilloscope. When I was measuring PWM, I think I used both. So,
okay. So when you say it's the voltage for the bad one, it was like the high was lower and the low was higher than the good side. Is that right?
Yeah. For the output, I always use the digital, like a voltmeter.
Oh, voltmeter. Okay, yeah.
So the sign is correct. It's just what I supposed to be like the 0 volt output is a relatively large voltage. So that made the drive like sluggish, because it's,
it didn't spin as much or as fast or whatever.
Yeah, and it seems I can't really find the relation. Like when I drive 255, it's normal, but when it's lower voltage, it's a problem. Yeah.
Are you supposed to have a pull down, a pull up, or something?
I think your voltage measurements might be being confused because you're probably not really at true ground.
I was using the ground of that input pin. So when I'm very low voltage, I have a 12 volt input. So I would use one is on the 0 volt, and the other one touches the output.
Okay. And one is 4 volts and one is 8 volts. Is that what you're saying?
Yeah, I think.
Are you talking about the output A and otherwise each output each H-bridge has 2 outputs? Okay.
Yep.
And are you saying that you measured, like where Carl's pointing to, you measured that 1 to ground and 2 to ground, and they're different?
Yeah, that's how I tell what is output 1 and output 2, is I measure against the ground.
On both of those?
Right.
Okay.
And so one of my motor drive board has 2 LEDs. What I find is that both are lighted. So it's like one is a bit dimmer, but both are lighted. That's why I was like, oh, that's strange. Because it's both has voltage.
I mean, it could be defective. We had some Monster Moto shields where I think I saw a similar thing, and the outputs just didn't quite ever turn off properly.
Yeah, it could be that one side of the bridge is bad, or maybe I don't know if those have the sense resistors.
But see, I switch one drive. I think it's the PWM drive because basically I have 2 of this identical board. I switch the PWM input, and the behavior goes together with the PWM. It's like the baud is, I can switch the baud, and it doesn't go with the baud. It's like the PWM. Well, I mean, it's correlating to the PWM, not to the baud. I can switch the baud, and it's
So two different boards give the same behavior with the same
yeah.
PWM.
Yeah.
Is one side using the lower frequency? You know, the 490.
Yeah, the lower frequency seems to be better.
And the other one,
I measured the other one is 30K.
yeah.
That one has problems.
Yeah. Yeah, you might get some different results. I'm not certain how fast you could switch the L298s. I mean, they're a fairly old part. I'd kind of be surprised it could do 30 kilohertz for a PWM frequency.
Yeah, the way I tend to use that part is in what they call sign magnitude, where you do PWM on one pin and essentially direction on the other of the inputs.
Yeah,
that works really well.
Yep.
Yep, that's the way you can do it.
You mean PWM on the enable? And
No.
Yes.
No,
Yes.
I'm talking about where you tie the enables high, always enabled, and you drive the two input pins, one with sine and one with PWM. So you only need 2 pins per motor.
You mean the
Yeah.
A and B?
Now,
oh my goodness.
One thing I found, so sign magnitude remind me, Dave, actually, is that when you give a PWM or magnitude of 0, is it actively braking or just coasting?
Well, it's actively braking. Essentially what you're doing is...
So that's what you want, right? You want
Yes.
that active braking. Yeah, okay.
Essentially what it is that you're doing the equivalent of a low impedance drive with a variable voltage.
But the key is you want to run it, you want to wire it up so that you get that active braking when your PWM is at 0, right? I think that's what you want. Okay.
Yes, absolutely.
So I have this A, B, and enable. Right now I drive 2 digital, like A and B are digital, and the enable is PWM. Is that correct way?
Well, that's one way of driving it. Not the way I like to do it, but it's one way of doing it.
Oh.
The way I like to do it is always enabled and drive A with essentially the polarity and B with the PWM.
Uh-huh. So enable is always positive. I see. A is the direction. A is the 0 or 5.
Right, and the other one's PWM.
Okay.
And that's so-called sign magnitude type drive.
And the enable, whichever stated.
John, I have that same L298 motor driver on the robot. It's right here. And when it runs, you can see that both lights are indeed off. See that?
Yeah.
It's just one is brighter than the other. The only way you'd have one light on totally is if you're at 100% PWM. If you're less than 100%, then both lights would be on, one less than the other. And as the reverse direction, that will reverse. I think I want to differ with what Dave said. I think in sign magnitude that you are coasting when you're at 0. And it's the locked anti-phase that gives you braking.
Now, I think locked antiphase is the third kind, actually, and I was going to ask if anybody's ever tried that, because locked antiphase, as I understand it, what happens when your PWM is at 50% duty cycle, you're technically switching back and forth between the 2 directions, right? But so that's locked antiphase. but that's different. So that's kind of the extreme way of driving it, I think. I've never tried it, but I've read that there are some benefits to it. But the braking versus coasting, right? Those are the other two types. The braking is if your PWM is at 0 duty cycle, you're just shorting out the motor terminals, right? So you're actively braking. And then the third kind is when your PWM is at 0 duty cycle, you're coasting. You're not doing anything. So those are the three types, as I understand it.
Yes, and the one that,
I'm sorry, Dave, go ahead.
yeah, the one I was referring to is where you have PWM, and when they're both at 0, or excuse me, when your sign is at 0, the PWM is at 0, you're doing braking. Why? Because you're essentially supplying 0 volts. In other words, with a sign magnitude, you essentially have a variable voltage driving the thing, and it's relatively low impedance because it's either direct drive from the power supply or it's shorted.
Let me back up a little bit then. If you looked at the L298 schematic somebody posted a minute ago, you can see that there's logic attached to those two transistor inputs. And basically what that does is keep you from turning the upper and the lower one on at the same time, which would basically give you a dead short. So if you think that the input, just think about one side for the moment. The input, there's an enable pin and there's a direction pin. Now, if you PWM the enable pin, control the direction with the direction pin, and that's called sign magnitude. You PWM the direction pin, just tie the enable pin to ground, and that's locked antiphase. And one of the differences is that when you have a 0 PWM in sign magnitude, that's when you have 0 voltage. When you have 50% PWM in locked antiphase, as Chris was describing, that's when you have 0 voltage. Basically, in that case, balancing the two sides against each other. And that's what locks it in my understanding. I've done both. I have robots that you can switch back and forth between them, so I can play with. I found that locked antiphase used a lot more battery. So I ended up going with sign magnitude. But my understanding of the sign magnitude, because what you're doing is you're controlling the direction of the direction. So that controls which two transistors are on. And then you're enabling.
Are you sure you've done locked antiphase, Dave?
Yes.
So you're saying to stop it, you gave it a 50% duty cycle to stop?
Yes, and in the case of locked antiphase, PWM drives the direction pin, and the enable pin is not driven, it's just tied to ground.
Okay.
In the case of sign magnitude, you're driving the enable pin, and the direction pin chooses which direction the...
Okay.
Well, I kind of okay, maybe in terms of terminology, but the way I understand the magnitude is that you use the driver that we showed the circuit of. Basically, if the enable is always on, then you essentially have two push-pull outputs that you are controlling. And you set one at either high or low, and then the other one you do PWM. And that gives you the sign magnitude form. And like Chris said, if you have the PWM of 0 and the direction of 0, then yes, indeed, you have braking. But even when you're doing, let's say, 0 and PWM, you in a sense are alternating between full drive and braking. And it's the percentage of that that's controlling what is the effective voltage on the motor.
Yeah, I don't remember what the terminology is. The locked interface, I think we're in agreement. But the braking versus the coasting, I don't know what the official terminology is for those two different ways of controlling it.
Well, yeah.
I think if you look at the 298, I said there's logic. There's NAND gates or AND gates that control 4 transistors. And the purpose of that is to prevent you from turning on an upper and a lower one at the same time. But it also prevents you from doing certain modes, because you can't, for example, turn on both of the lower ones at the same time, which is what you want if you want to break it. That is, you want the motor regeneratively tied back to the battery in order to break it.
No, well, okay. You can, if you
So
are.
you don't actually have 3 inputs. You only have 2.
No, you've got 3 inputs. You've got the enable and then the in1 and in2 for each side.
But those must be kept 90 degrees out of. I'm sorry, those must be kept 180 degrees out of phase with each other.
No, they don't have to be 180. That's only if you're doing the anti-lock. If you are doing sign magnitude, you have one at one level and you PWM the other.
Okay, maybe I haven't actually done that. What I have done, as I said, if you back up, you basically have 2 inputs to each side. You have an enable and you have a direction. Now the direction is controlled by setting those 2 pins. But normally those are there's a logic that drives that to prevent you from turning on the top and the bottom one at the same time. And I believe that's what those logic gates in there are doing.
Absolutely, but if you look at it, the output 1 and the output 2 compared to the in1 and in2 are just basically buffered outputs. So whatever you drive, if you have it enabled, if you drive in1, then the output, if you drive it high, then output
I see, David. Yes.
You see what I'm driving at?
Yeah, I got you.
And so what I'm saying is that if you always have it enabled, you could take, say, in1 and use that as the sign and do a PWM on the 2. And that gives you the sign magnitude. And as Chris said, if you have that direction at 0 and the PWM is 0, then yes, indeed, it's full braking. On the other hand, if you have the direction at full 1 and the other one PWM at 100%, then it's full braking the other direction. But the in between, so if you do the direction is and PWM, then you are in effect using it as sign magnitude. And what you do is that if you take the PWM value and you use the sign of the PWM value to drive the 1 pin and the lower bits to drive the PWM value, then you get in effect a sign magnitude drive, and it's always in effect low impedance because it's alternating between it being shorted with full power and shorted with no power.
Does somebody have a schematic of that little device right there? Does it have any other active? Does it have any other active components?
That was the schematic we were just looking at.
Yeah, it's
No, that was the schematic.
I
thought that was the schematic for the L298 itself.
Yeah, I think it was.
Oh yeah. Okay. Yeah. Yeah.
Yeah, that board typically has like I think 8 Schottky diodes. One,
Yeah.
One to
The
supply.
only thing that board adds is Schottky diodes for the outputs so that you don't burn up things. And then the other is it also has a voltage 5-volt regulator.
Right. Yeah, because that pain in the neck part needed 5 volts.
In other words, that other chip that's roughly in the middle there, that's your 5-volt regulator. Right there. Yep.
Yeah, right there. Yep. And those diodes may change how it actually breaks because now it doesn't have to break or send current through one of the transistors. It can send it through one of the Schottky diodes.
Well, those Schottky diodes go to the ground and supply voltage to keep it from going above or below the supply or ground voltage and blowing out your transistors.
Yeah. But it can also be like a discharge path or like regenerative braking. It can actually send current through the diode.
Yeah.
The transistor.
That's in the case where you're using the enable pin.
Mm-hmm. Yep.
On the other hand, if you're doing a signed magnitude, you're always driving it hard one way or the other.
Yeah. So John, it sounds like you've isolated it. If you think it tracks with PWM, right? If you swap one of the PWM signals, the issue kind of follows that signal. Is that right?
Yeah.
Okay.
Yes.
Well,
does the L298 allow, say, 30 kilohertz PWM?
That seems high. I don't know, and that's a fairly.
I don't remember
20 years
how
old.
high that one will go.
Yeah, I don't know if it'll go up to 30.
So if I use say a 500 hertz PWM, is that? I mean, there's noise, but any other issue with the efficiency?
I wouldn't think so. I know some of the switching times in that part are they're not in nanoseconds, they're in microseconds.
Yeah.
So it's not the part in the world.
I've driven these up to 20 kilohertz. I find that it's nice to get the PWM frequency up above
audio
range, above the range of hearing, because it can be really obnoxious. But I've driven them at 20 kilohertz and they work fine.
I see. Okay.
Probably just gonna heat up more.
Yeah.
Because, you know,
So,
you're in the switching zone a lot more.
What I get is it's normal. Both the output 1 and output 2 has voltage. It's expected, right?
Yeah, but you'd think they'd be the same. It's kind of odd that it, like you said,
Hey, David.
tracking PWM.
Yeah.
David, the other David. David, you say you're running yours at 20 kilohertz.
Which David?
You. Are you running? You say you're running your PWMs at 20 kilohertz, right? So you don't have to hear it, right? Did you on these? But you're using the Fitman motors, right? Okay. What I'm trying to figure out is how linear is your voltage to speed? Is it very linear, or do you have a scoop? Usually they have a scoop, but sometimes they have a.
It's reasonably linear. You know, it's actually kind of like that, right?
Okay.
You're doing signed magnitude tends to give you more of a linear.
Does it? Yeah. And
Where
Chris,
if you let it coast, then it's really wild.
Chris, you actually tried to linearize your motors, didn't you? You looked at PWM and speed and.
Yeah, I mean, I was doing what I call like feed forward. I looked at the motor voltage to know, you know, what PWM duty cycle is going to give me the desired speed. So I didn't really have to use full PID. But I think that's a little different from what Dave Ackley is talking about in terms of linear response versus, you know, a little bit of a curve.
Yeah, if you're measuring the current, then it will tend to be more linear.
Yeah, I didn't measure it, and again, I was Googling all this time. I can't find the correct terminology, right? There's sign magnitude and locked antiphase. I still don't know what the third is, right? What are you coasting versus braking? I don't know which one is sign magnitude. I'm not convinced we got that terminology right, and I can't seem to find it. You know, but there are those three types. I think we can agree on that, but we only have two terms right now. It bothers me that we can't find the third term, you know, for the third type of PWM control.
Yeah, by the way, I just looked up the data sheet on the L298 298 and it is 40 kilohertz is max.
Yeah.
Okay.
Yeah, maybe it should do
Dave, I have actually, in a previous robot, long ago, I actually built a table and linearized the spots. But the problem with that is that it varies with load. It varies with load, and we're making a simplifying assumption that frequency varies with frequency, that RPM varies with voltage, and it doesn't really. It's proportional to current. And so that turned out to be unnecessary once I got the bid controller working, because the bid controller linearized the response. If you see what I mean.
I'm sorry, I didn't quite follow that, but
Yeah, you broke up a little. Can you say it again?
I was.
I think we need to all pitch in and get Dave a better audio setup, because it's really a shame that we can only hear half the things that Dave is saying.
Although maybe that's about right.
One more question for you, Dave. You said you did try locked anti-phase, and then you said something about, I mean, it didn't work out well. You didn't like it. There was some disadvantage. I always wanted to try it, but never have. Only read about that there might be some advantages. But so, what did you find with locked anti-phase? Was it beneficial? Was it disadvantageous?
Well, let me offer a caveat there, which is that one of my robots, the outdoor robot, the 6-wheel robot, does use locked anti-phase. But I found for the other robot that it used a whole lot more battery. Really ate up a lot more battery than sine magnitude, and I wasn't willing. It didn't improve performance enough to be worth it.
Okay.
yeah, that's the because you're essentially driving 50% each way. You're dissipating a lot of power without doing anything.
And you know, if those transistors are not switching instantaneously, then when you're sitting still, a little bit of that going into heat. And you know, there's instantaneous and there's instantaneous, but you know, basically with one turning on while the other's turning off, unless that's really, really fast, you do lose something.
But in theory, I mean, what is it supposed to give you more of? Like better control? It kind of maintains the magnetic flux more, or something like that, right? That there's supposed to be a benefit to it.
I thought what it was is that each cycle you're getting rid of any inductive energy or energy held in the inductance of the winding, and that's why it takes more power, kind of like what you were saying. So you can actually kind of use, if you're coasting and you're not, let's see, how would you say, if you're not braking, you can use that inertia, keep the thing rolling. It'll basically take less energy to keep the platform or, you know, the motor spinning.
But even with sine magnitude, where you're coasting when in the negative half of the phase, basically, you're only driving in the positive half of the phase. Even then, if the robot starts going downhill, the bid controller will back off, and it will effectively brake by running the motor slower or even backwards if required. So the bid controller fixes those problems. That's especially apparent on a balancing robot. When I ran it with locked anti-phase, I don't know how to describe it. It was more rigid, therefore it balanced less well.
Maybe that's the lock in the.
All right. Well, that was a pretty good little discussion starter then. That's,
Did that solve your problem, John?
You know, I thought I knew something, but I didn't even really understand how I should drive this guy. So
Have
I'll
you
look out.
looked at the PWM pin that drives it? Is it a, you know, is it a valid low and a valid high? It's kind of odd that it tracks PWM and it changes that much between, you know, roughly 500 hertz to roughly 1,000 hertz. You wouldn't think that would make that much difference.
Oh, it's the 501 hertz, 1 kilohertz is similar. It's the 130 kilohertz is
Oh,
it's
that's
different.
different.
Yeah,
Okay.
yeah.
But
I
you
mean,
know,
I'll experiment a little bit. I'm gonna try what David actually is mentioning, this called the sine magnitude drive. I'll just see
Yeah.
how the yeah, I'll try it out. I'm changing too many hardware, like the motor drive board, the motor wiring. So I'll come back later. and
You
then-
previously said you have a little logic analyzer, one of those $15 ones, or do you not have one of those?
I have an oscilloscope. I can see that PWM
Okay.
signal.
Yeah.
Do you have enough channels there? So you have a 2-channel oscilloscope?
Four
All right.
channel, yeah.
so when you
Yeah.
zoom into the edges, John, on the PWM, are the edges nice and square, or
Oh,
are they really kind of gradual and rounded?
it's a little overshoot, like a little bit ring.
A little rings, a little
Yeah.
ring is okay, but what I was wondering is that if the drive pins, like if the cable had too much capacitance, like is really long or a bad cable, or if the drive pins were not very strong, then it might take a while. Instead of being a nice sharp transition on the PWM, it might be a gradual slow thing.
Mhm.
And if it's a gradual slow thing, then it's not going to work as well.
Mhm.
You want it to be a
Um,
nice fast transition.
Yeah. I mean, 4 of the pins, the 3 of them have very nice PWM signal. One is funky. I mean, I don't know whether it's wiring or not, but it's like
Get a screenshot for us on the next meeting. And
I can do that. Yeah, I mean, maybe it's just wiring, but yeah, I
Also,
think
John,
I'm
remember
just
that
running on the shoestring, so I have to
remember
make
that
my system better.
the H-bridge is connected to the motors. So those those big mechanical things with great big coils on them, and you're charging those and discharging those coils, so that becomes part of the circuit. It's not just that nice clean signal that's exiting the board, and also that as Ray pointed out, there's a bunch of shotkeys on that board specifically to help you with the back EMF that happens when those fields collapse. So there's a lot more going on there than just what's happening in the board. You have to remember that the motor itself is the circuit.
When I was marrying the PWM, I was disconnected from the board, from the motor board, because it's the pin. So you think I should measure it while it's driving, right?
Well, but so you were measuring it while disconnected, and you still saw something strange. Is that what you're saying?
Yeah, the PWM one of the 4 is just.
Again, I wonder if you need to turn on some pull up or pull down. Maybe you're just driving the pin in one direction and not in the other direction. It floats,
Right.
and
Right.
so you got to do look into pull up or pull down.
Exactly that. So look at and that's what I'm getting at, because I agree with you, David, that the output, especially with the flyback and the shotkeys and all that messy stuff with the inductors and all that stuff, that's going to disturb things. But if you can't get a clean square edge into the driver chip to begin with, then it doesn't really matter, right? And I think that's what Chris and I are talking about, which with all these Arduinos and these tri-state bidirectional pins and all this programmability. I mean, if you're not really careful about how you've initialized, and actually, John, if I remember right, wait a minute, you're using the same robot that I am, aren't you? Or the same
Motors. I took the motors out. I'm using some Pololo motors now.
Some blower motors, but are you using the same drive circuit that came with the motors?
Oh no. So I mean those motors. Yeah, I just gave them up. I have.
Okay, well, no worries. The only reason I mention that is that because I remember the early days of this guy with its Mecanum wheels. The early days, I discovered the hard way. It cost a whole weekend or so to figure out that I had pulled this commercial thing out of the box and hooked it up correctly. I mean, how can you not with ribbon cables? The trouble was is that the software that they gave was out of date compared to the circuit card that they gave. So you use their software and it would send the like IN1 to one of the motors, but it was driving the wrong pin. So the motor driver was getting a tri-state input instead of the actual input because they had moved it to another pin of circuit card and they didn't keep the software in sync with the schematic.
I see. You know those motors. I
The
looked
other
at
thing
the
I
two.
is I just put on the meeting there under my name is an article that talks about the sign magnitude versus the locked antiphase.
I see.
Cool.
I see. Yeah. So the motors I bought together with the wheels, the encoder signal, like one signal is nice and square. The other one is really strange. So I mean, and two of the motors, so I have 6 motors from them. 2 doesn't rotate, 2 doesn't have encoder, and 2 has encoder with 1 channel. That's really weird. So I just
But they were
gave
cheap.
them up.
Oh man, I complained to them. They responded well to me when I had a couple of minor issues.
Yeah, I don't know.
Even on Alibaba, they responded well. Mobius Tech.
Yeah.
Yeah.
Anyway, yeah. So yeah, I'll look at the new drive and see if it's gonna solve my problem. And there's probably more in my problem here, but I'll dig into a little bit and share next week.
I know if if you're running, well, okay, if you have issues at the 30 kilohertz PWM, I kind of wonder if it's just, not what that motor prefers to be driven by. So, if it's a much higher inductance, probably, I know a pair of the Palula motors that I got, I could, they just seemed to suck my batteries down, but I think they had a stall current of 8 amps each. And so,
I see.
I wonder what Palulu recommends to drive those motor, what PWM rate, do they say
They have this. They have this information. It's
They
one of
might.
the high power motor. It's like
When I look at Pololu motors, they have a recommendation of the max torque that the gearbox can take, and you always try to pick a value below that number, because if you don't, it can destroy itself very quickly, by the way. And 8 amps, that sounds like you had the high power version,
Right. Yeah.
And you have to be really careful there because, like I say, some of those motors are so powerful that if they get in a stall situation, it just eats the whole thing up.
They're very quick to smoke.
Yeah. So you have to. They do have that down on their website. They'll tell you that this series of motors don't go above this torque.
Right.
And you just
I don't
have
know
to.
if they have recommended frequencies for PWM or not, though. I haven't looked.
No.
No.
That I think we just have to play with to see and get the data.
Yeah. But if you,
I'll be interested in what David has been saying. I'm talking about. I'm going to look over the article he posted and see if because I've just been using the spec sheet pretty much, and it works. I've never had problems with it. I mean, that to me is a solved problem. I've never even had to worry about it. So I don't know. And they're so easy to work with. Gene, I'm having a little question, you may just have a bad one. If it's not,
Yeah.
if it's following, each one of those, that board you have has actually controls two motors. So it has two H bridges on it. So if you move it over and the problem follows the H bridge you're using, that sounds like that's a problem with that H bridge.
Oh, didn't you say it followed the higher frequency PWM?
Follows the PWM. So it started when I was
Okay.
trying this feedback. I mean, it's like it's identical 4 motors, identical 2 motor board, and the feedback. What I see is one doesn't follow well. So I think the reason I think is the deadband is much higher for the one that I can't drive efficiently. So basically, it doesn't do anything, and then it goes and overshoots. So I realized why it doesn't drive so good. I look at the 2 output. So it's like chain of event.
Yeah, one thing that you can do really quick to kind of get a feel of motor match like that is just what if you run it at half of your motor speed, okay, and just see if there's a significant difference in their well, probably not half, probably quarter of the voltage, and see if one is running a lot faster than the other one. Okay, that will tell you that there is something weird about one of the motors. And use the same H bridge. Use the same H bridge. Use the same H bridge on all of the motors as you test them. Okay, so you keep that as a constant in your experiment, and just see if a motor, if they all respond. They're not going to be exactly the same, but if you got one that's running at a third of the speed of the other 3, you got a problem with that motor.
You didn't do what Carl did. You didn't super glue anything, right?
What did Carl do?
Okay. What Carl did was on the first iteration of this guy, the first one I bought came with a nice laser cut plastic plate. And I thought I'm going to make this thing last, the vibration and stuff. So I got really clever, and when I mounted the brackets to it, I used Loctite. Little did I know before then that 2 problems. Loctite attacks plastic, certain kinds of plastic. So after about a day of just like picking up and setting it down, stress fractures emanated from everywhere the Loctite touched. So basically it just shattered. So the other problem I discovered was that Loctite in the mounts of the screws, where you mount the motors to the bracket there. I thought I was being really clever in how I was getting the Loctite in there, but I was a little too clever, and they got inside the motors. It was doing a good job of locking the motor shaft to the slip bearing.
So it worked. It worked.
I was wondering, like, wow, what terrible motors. This one motor spins pretty good, and the other 2 motors, I mean, they're crappy motors. And then I thought, wait a second, blue Loctite. So I spent another afternoon and I took the motors apart, cleaned up the blue Loctite, and now, well, I have 4 spare motors. Because by that time I'd already purchased another set.
But it's gonna touch your gear box only, right? It's not gonna touch the wires.
Right? But the Loctite is so it's everywhere. And I thought I was being clever because I took little pincers and I just got a little bit on the pincers there, and I dabbled it in a screw hole, and when I threaded it in,
yeah, he Loctite the gears.
I locked. It wasn't the gears actually, because there's only one gear by there. It's like one big gear and then a small gear on the shaft. Although some Loctite actually did get that far. The Loctite that was the problem was the Loctite that got onto the shaft.
Oh, the bushing, yeah.
Enough between the shaft and the bushing, and yeah. So thanks for reminding me of that. That was
sorry.
You know, if we can only get rid of COVID and go back to where it was just Loctite on the motors bearings,
That'd be
it'd be a
easy.
happy world.
Well, you know, that's good. It just proves that Loctite works. It does its job.
Yeah. At least nobody suggested using Loctite to get rid of the virus, right? So
Oh,
Yeah.
let's hope not. Although,
Yeah, I mean, hardware is so tedious, guys. I was just, I mean, I was crimping wires, wanted to get it work, and yeah, I mean, now I have to do more homework. I thought it's gonna work now. Yeah, all right, I'll report back and see if I can understand.
Okay,
this
hey
better.
Dave, just to make it absolutely clear what you're doing, can you in the chat, I mean, I don't know if you can do it in the chat, put the state you're putting the motor controller in, you know, just your high, low, PWM, whatever, so I can make sure I understand what you're saying. Okay, you know, you have input 1, input 2, and enable. And if it, you know, what states are you're saying you're tying the enables to 1, right?
You mean
Yeah.
you're asking Dave or me?
You're muted, David.
Dave, yeah.
Dave, you're muted.
David Anderson.
Yeah.
No, actually.
Okay. So what I'm saying is that if you take that particular module, they've got it's set up so you can put jumpers on the enable pins.
Yes.
Okay.
Yes,
So
you can.
jumper the enable pins, which means it's always there. Both of them
Set to 1.
enabled.
Yeah.
Okay. And then on one pin, you put essentially the sign value.
Sign value. What's the sign value?
Okay. Take your PWM value. Okay. Imagine it's a signed value. Okay. So it goes from you know, minus 256 to plus 256. Okay.
All right.
Okay. Now, if you take the lower order bits, that is all but the sign bit, run the PWM with that value, and take the sign bit and run it on the other pin, then it'll give you a continuous from 100% drive one direction to 100% drive the other direction. Right, David Anderson?
Well, I was just looking back at my own implementation here, and I actually have logic that sits in front of that drives both of those pins. So I actually, for each side, I just have 2 inputs. I have an enable input and I have a direction. So basically that means I can't do braking.
Okay. Well, in the arrangement I told you, where you have the sign bit goes to one pin and the PWM lower bits essentially go to the other pin, then it's really, if you put 0, 0 in, I mean, the 0 value in, then you've got full braking.
Okay, take me through the logic of that.
Okay. Let's say you've got a 8-bit value that's your.
No, I understand that part. I mean, in order to get braking, basically what you have to do is both bottom halves of an H have to be turned on. Bottom half of both H have to be turned on.
Right.
And the way I have it set up, I can't do that because I have this logic in front of it.
I
So
understand.
when you put 0 on the direction pin, at least in my implementation, that sets it up to go forward. And 1 on the direction pin sets it up to go reverse.
Right. And what I'm saying is I'm not putting any logic between the processor and the bridge. I'm simply taking input 1 and driving it with a sign value, and input 2 and driving it with a PWM value. And that's.
If you look at that actual little board that he has, if you look at the input, there's actually 2 jumpers. And what those jumpers allow connect the enable pins to ground or plus, whatever it is.
Exactly.
So that you don't need enable pins, you just use those other two.
Exactly. That's how I'm talking about driving it. And what I'm saying is that if you take the drive value, PWM value as a signed value, and you take the most significant bit, and that drives one of the pins, and the lower bits go through the PWM. And if you set that all to 0, then you have full braking and no drive. And if you set it to max value, then you have full drive in one direction. And if you set the opposite value, negative value, then you have full drive in the opposite direction. And then you've got anything in between.
Yeah, that's my understanding as well.
Cool.
What if I put enable as low voltage? When David window drive, you have, what if enable is like 0 volt?
Well, I don't remember what it is for that one. It's just that if you put the jumpers in where the enables are, it says that it's fully, all of them are enabled.
Yeah, I think it's active high for the enables.
Yeah, I think I want to say it's high.
Yeah, I don't remember whether it's high or low, but anyhow, with the jumpers in there, you have essentially enabled the bridge.
Ah, right. Yeah, right. It's next to each other. Okay, I see what you mean. Wait, where is the 5 volt from? Okay, I'll look at it. Yeah, it's right next to the 5 volt.
If the board itself is set up so that you can put jumpers on the enables.
Yeah, I see. Right, it's next to the 5
You
volt.
don't need to drive the enables at all. You just use the other pins. Yeah.
Sean, those are on my board at any rate. The little jumpers are parallel. Sorry, at right angle to where you actually connect the control pins.
Right.
There's a little jumper at each end.
Yep. Exactly. Yep.
I see. Cool. Thanks, guys.
And so that means you're using the lower 7 bits to set the speed.
Yes.
Okay, so the
Or you
lower
can
7
use
bits,
the
so plus or
9-bit
minus.
whatever you want, but yes.
Huh?
Yeah, you can use a 9-bit value or whatever it is that your PWM will accept. You use that many bits for that. So you have the number of bits that your PWM controller will take plus 1 for the sign is how many bits you would come out of your PID controller with.
Yeah, I think like I explained to Jack Jones, he was saying he was doing something and it wasn't working well, and I said, well, just don't do that then. So, don't use that 30 kilohertz, high frequency.
Yeah, I'll use David's suggestions. And yeah, right. Whatever works. Actually,
Yeah.
I think what I have seems to be working. So
Yeah.
for like a few hours, it seems to be working now. But yeah, I still want to know. Yeah. All right. Yeah. Thanks, guys. I really learned a lot. So I mean, I want to go. I don't want to take more time from you guys now. So yeah, thanks.
Cool. All right. Well, that was a good leading question.
Yeah.
Excellent. All right. Well, let's swing around. Let's go far north at this point. So I was chatting with our latest visitor, Pat, from Northern Ontario earlier, and just wanted to welcome welcome to Pat tonight. Thanks for joining us in person. And if you're still available or interested, it'd be pretty cool to hear what your robot project is, and I bet there'd be some interested even in what you were talking about earlier with the sawmills you work at.
Okay.
Oh,
Hi, everybody. Basically, I've been working in robotics for too long, several decades. Built some 2 servo walkers, a couple of 2-wheel robots with differential drive, and I started working on this a couple of years ago on a larger robot. And I'll see if I can bring it up on my video. Switch cameras. So I don't know if you guys can see that.
Yep.
So it's about 14 inches long, about 16 inches wide from outside wheel to outside wheel. Weighs about 25, 30 pounds right now. It's using a wheelchair solid lead acid battery. I'm currently waiting on a motor driver. My last motor driver failed. It had an Arduino integrated into the motor driver, and I was having a problem where it wasn't resetting. It wasn't coming out of reset properly. So I was no longer able to change the program in it. So I've switched it out. I've ordered I guess it's a Pololu clone on a VNH 5019, I believe it is.
Yeah.
Motor driver. And it's driving a couple RS550 motors and some Bane box gearbox underneath.
Heavy duty.
So yeah, it's pretty heavy duty. I wanted something that I couldn't step on. So seeing how it's about 16 inches tall, I don't think I'll step on it easily.
Hey, Pat, how big are the wheels there?
Those are approximately 6 inches.
Okay.
So I had
Are they from the wheelchair, or did you?
No, those are from a surplus store we have up in Canada called Princess Auto. And they're just a little pneumatic tire, 6-inch pneumatic tire.
Okay. Okay.
I don't see any caster, at least not in the front there.
There is a caster at the back underneath. The weight is towards the back end a little bit. There's a caster, a swivel caster under the battery. Okay. So I've got it up on a. Pardon me?
Can we see the caster?
Oh, yeah. So let me pull a million things off of it. So I don't know if you can see that.
Yeah.
Yeah.
So
okay.
I've got the caster under there. I've got a couple of motors hidden underneath some covers.
Yeah, looks like cans, huh?
Yeah, a couple cans so that I don't catch anything underneath.
Tin can motors then.
Exactly, tin can motors. And then I've got a 6 SR04 ultrasonic sensors all the way around. And currently they're talking to a little Arduino Nano. So the old motor driver and the Nano were both communicating before on ROS1. And they were communicating back to a Raspberry Pi. And I was just using ROS for communications. I wasn't programming anything else in it. It just makes it really easy to send signals back across the USB ports.
So is that going to roam around the house or any other? Do you have a specific task for it, or just roaming around?
Just roaming around. I don't have a dog or a cat, so it's going to be my dog or cat.
Hey, Pat.
Yep.
You might also. It just so happens that Pololu's got a sale going on right now, and this is an interesting sensor that you might be interested in. It's a
put it in the chat.
Yeah, it's 160 degree 1 meter time of flight POF sensor. And it's 20% off, so it's about $20, I think, right now. It's normally higher than that, but because of the sale, it's about $20. Anyway, this might be of interest. or something. It looked interesting. I hadn't seen it before. And it has essentially 3 sensors that are arrayed. So you have approximately 50 to 60 degrees view with each of the 3 sensors. And they, you can take readings, you can average them. So like each reading is like 1/4 of a millisecond. So you can say like, well, take 5 readings and average it, and you're still out at a millisecond and 1/4. So they're sounds pretty good from that point of view, you know. So I thought it would be something that people might be interested in as a replacement for the SRO4s. I mean, I'm not saying that, you know, SRO4s are great, and if things are in close, they're really fast. My experience, you know, but when you're running 6 of them, how are you firing them? Are you firing them like 2 at a time or 3 at a time? Or
I'm firing six at a time.
6 at a time.
Yeah, so I'm firing 6 at a time, and then I'm looking at for a pin change interrupt on
Okay.
the map again.
And you're not worried about cross, you know, pickup or whatever the right word is?
So far, it's been very good. I get the occasional sporadic reading that's way out, but so far it's been quite stable.
Mm-hmm.
I'm just worried about, you know, different things. You know, does it spot a coat laying on the ground or something, or hanging off a chair that I may not be able to spot it, and then it gets tangled in a wheel.
Yeah.
So that's where possibly the time of flight sensor might be better.
I'm not saying it's better. I'm just saying it's interesting. I hadn't quite seen one like that before.
Yeah.
And so
it's interesting, but pricey, $30.
Everything's pricey in Canada because that's
It's
$50 Canadian.
Yeah.
But the other one is eventually a camera as well, sort of forward, down facing at about 30-degree angle or so to be able to spot anything coming in the path.
Mm-hmm.
So Carl was saying you're doing something with a lumber mill or something?
Yeah, I work for a company in Canada. Basically, we have 9 mills. So we have 7 sawmills and 2 secondary manufacturing mills. So one of them makes like bed frame lumber. So it'll take our reject pieces and make it into bed frame lumber. The other one makes eye joists for floors. So wooden eye joists.
Yeah.
And
any robots in use there?
No. So we're doing some. We use some vision sensors. I do some stuff with some Cognex sensors. We use some Keonc sensors for at our eye joist plant to look at the finger jointing. So as the board gets finger jointed, we look for tear out in the finger joints prior to gluing, and so we can reject the piece. Aside from that, there's a lot of automation. There's way more than I ever thought. I've been in the sawmill industry now for 19 years. Wow. And there's way more data than I thought there would be when I first went there. I thought everything was going to be, you know, a PLC would start and stop motors and, you know, maybe set a speed on a conveyor. But it does all of that. But it's one thing is everything moves in a sawmill. So there's motion control where we're bringing in some bandsaws that are let's say 5 tons each. We're moving those at 6 feet a second, basically. The acceleration is huge on those, and you don't want to get them in an oscillation as you're moving them. I do a lot of PLC programming. They're all still there.
That's good.
I do a lot of PLC programming, so I'm using a lot of Rockwell Control Logics, old Allen Bradley PLC5, a little bit of Omron CX1. Siemens, I hate Siemens. I've worked in it. It's a nightmare.
what we used to stop the Iranians from developing their nuclear program.
I got to commend the U.S. on that. That was brilliant.
Got it air gapped. Huh?
Yeah, that was a really, really good virus. If you read up on it, it's phenomenal how big it was, how huge it is, and what it was doing. So, but that's it. So I worked at any one of 9 different mills, traveled back and forth. COVID has been friendly to me. I'm in my living room right now. I've got a desk that's about 6 feet away, and I've been doing a lot of work at home on basically dashboard systems lately, where we're just gathering KPIs from the mills and making them available to all of the mills plus corporate.
Huh. Is the company that you work for, is it Weyerhaeuser or?
No, it's Ecom Timber Corporation. It's EACOM as Michael.
Yeah.
Ecom Timber Corporation. It's a small timber company in Ontario and Quebec.
Okay. Huh.
So I guess that's why your robot's mainly made out of wood. Now that explains it.
No, wood is easy to work with. It's big. It's, you're not working on little things and little tiny motor, although I can't take it with me when I hit the road.
Hey, there was
I have to say that I've run into this. There's sort of a trade-off between big enough that I can get my hands in it and work on it without breaking things, versus too big to carry. So, and I had made a rule for myself a long time ago that I didn't want a robot that was too heavy for me to carry or that was faster than me, especially an outdoor robot. That you're just asking for trouble. I always want to be able to outrun it. I don't know if this would be of value to what you're working on, but here's a handy robot. I've used a lot of those SRF4s, and now that part of this goes with the philosophy of the control, which is that I'm primarily interested in things that are ahead of the robot, not so much beside or behind it. And you see the 2 of those that are mounted off from each other just about 10 degrees. And I found that gives me pretty robust front object avoidance and so forth. With just a single one up front, you're going to miss a lot. You're going to miss a lot of things.
I have 2 at about a 45-degree angle and 1 forward-looking.
It's also useful to have sensors in pairs because basically what you're trying to do is, should I turn left or right? And when you only have a single forward-looking sonar, it's harder to make that decision. I have determined.
I was hoping to use the camera for that.
Well, when you say use the camera, that covers a lot of sins. I set this robot down at a Christmas party at the university a few years ago. I let it run around during the Christmas party, and it can navigate pretty well on its own. And a lot of people would come up and say, how does it navigate on its own? Does it have a camera? And the way the question is phrased, it doesn't have a camera, but the way the question is phrased, it suggests that if I said yes, the question would be answered. Oh, it can see. I can see. It can see. Problem solved. But actually to take that flat array of pixels and turn it into anything meaningful is not a trivial process by any means. It's much easier to navigate by having a sensor like an IR or a sonar tell you, is there something there? Just my 2 cents worth.
Yeah, exactly. That's why that time of flight sensor looks interesting to me as well, because forward sensing, it would give me a good picture of what's in front.
Yeah.
We have one of the hardest problems in robotics, from my perspective, is what I would call perception. And it's because it's so easy for us humans to do. When we look at something and we perceive complex interactions and complex relationships, and we break different sensor inputs up into objects, and we classify those objects, and that's all almost done automatically by us in hardware. It's not like doing math. You don't have to work at it. It just happens. But that stuff turns out to be really, really hard for a robot to do, to look at a scene and to break it up into objects and know how those objects interact with each other is just really, really hard.
Yes, it is. I deal with vision systems at work, and what's easy for you to tell that there's something in the picture, it's hard to analyze it and actually have it detect it.
Do you use any like OpenCV stuff or?
No, I've been at work. I use Cognex.
Cognex. Oh.
So Cognex is vision-based sensor. It's
basically a smart camera, right? They make smart cameras.
Yeah. So it's got a bunch of different. It's got essentially OpenCV type tools in it.
Yeah.
But it's made to communicate with other pieces of equipment, so it'll communicate very well with Allen Bradley PLCs or ControlLogix.
Yeah.
On the robot, yeah, it would be OpenCV.
Yeah. Yeah.
So that's about it. It's been a slow going process. I've ordered the motor driver. I ordered 2 weeks ago, 10 days ago from China. So it'll be here in February.
Probably, yeah.
So that's same story as everywhere, depending where you order it. If I wanted to get it sooner, I could have bought it, let's say, from Polulu. But then let's say it's $50 US. It's going to be $75 by the time it gets here.
Ooh.
So it's right now it's about 40% on the dollar.
Is it? Yeah. Yeah, my wife and I actually went up to Western Canada, Glacier Waterton Park, Banff. Trying to remember what some of the other places were, but it was basically a bus tour. A lot of fun, really beautiful places. I grew up in New York State, and realized that some of the Canadians that like from Quebec spoke French, but I didn't think that got to the western side for some reason. I was really kind of surprised to see bilingual signs even there.
Oh yeah, Alberta has a lot of bilingual signs.
Yeah.
Plus, there's a lot of tourism in, like you mentioned, Banff. It's a very tourist town.
Yep. Yeah.
Whistler and Banff are two of the biggest ski resorts in Canada.
Yep.
I was there pre-COVID a year and a half ago. So,
yeah.
I have two sons that are out west in Alberta. So I haven't seen them with COVID now. It's been a year and a half. So I was there a year and a half ago in June. We had plans for last June and couldn't make it. So it was a full year before that.
Huh. Yeah. I don't know how the vaccinations are going here, but it seems like there's been a stall in the United
Same
States.
here. They shut down in Ontario at Christmas for 2 days. They weren't doing any. And now we're waiting, but where you are on the list, if you're not a healthcare worker right now, or you're not in an old age home, you're lower than that on the list.
Yep. Yeah. Yeah, it's kind of unfortunate. Hopefully that's all going to change next year.
Well, I'm hoping by June things are back to semi-normal, and I'm working towards pre-retirement here, so take 3 weeks off or something in June and go for 3-4 weeks, go for a drive west and see the kids.
Sounds great.
And then who knows? COVID gets healed. Maybe the year after into the States. Go west, head south, take about a month and a half, 2 months off, and drive around.
It may all
come
be
down for our
the time anyway.
come for our competition.
Your competition. I'll have to buy a bigger truck to bring my robot.
Yeah.
You can drive a robot. Have it tow your truck.
There you go.
Send it on ahead.
Yeah, I do that with tools. I'll send all my tools and stuff on. I'll Purelate them or UPS them or whatever across the country.
Question on how are you planning to program it? Yeah, I think you mentioned the Raspberry Pi. Is that going to run all your software?
Well, I'm offloading the motor control to the Arduino. basically because I want to do the PID loops and everything inside the Arduino, so that basically I give it a direction and a speed. So go forward at 70% or 1 meter per second.
Okay. And then on the Pi, sort of at the higher level of software, are you planning to follow any particular, let's call it style or paradigm? Like, are you going to do something with a little bit more planning in it, or purely reactive, or how do you see that coming about?
I'm looking at developing in Python probably some subsumption architecture to basically have it have priorities and decide what to do.
Oh, our friend from New Zealand is not on today, but he's that would resonate with him.
Yeah, I've been listening to him, basically talking about it with some interest, but that's what I differ a little bit, is that I'm trying to get the motor control and everything done in an Arduino and let it do what it needs to do, react quickly to timing signals, and leave the upper functions to the Raspberry Pi. So the Raspberry Pi can interface to a camera, can come up with an idea on what it's going to do. And the Arduino just tells it, hey, my battery's low, or I've got an overload condition on one motor, or whatever the case may be.
Okay. And so you said, so camera, do you know yet? Do you know already how you're going to do the computer vision, OpenCV or some neural net? Or what's the plan there?
So far, I've been playing around a little bit with OpenCV, doing a little bit of edge detection and trying to figure out how I would detect an obstacle and avoid it. You can do some training and neural nets and stuff like that, but there's a lot of different conditions in a house when the robot's roaming around.
Yeah.
So the data set, I think, would be huge to try to learn everything, what to do in every circumstance.
Yeah.
Have you heard of Pi image search? It's a website.
Okay.
Yeah. Pi image search. It's all strung together. There's a guy named Adrian Rosebeck, I think, that runs it. He has tons of OpenCV examples. Everything from like very simple beginner stuff, kind of the, I'm trying to think of like morphism, how to do edge detection, how to do blob detection. He gets into some really very sophisticated stuff now, and he sells books and that kind of stuff. But if you any question that you have, you can look at his, I don't know how many examples he has now, hundreds, of pieces of code that are in OpenCV that you can use to do something with.
Yeah.
And
I find OpenCV has a lot of good documentation on it, and I find it simple to follow through and to see how it works. You can do it in Python, or you can do it in C++. I find it's really good. I've also tried to do different things on ROS, and I had one working. My previous robot was working with remote control in ROS 1, and that's, I find, is an uphill battle to get anything done in. The only thing I really liked on it is the underlying communication between everything just works so well. You didn't have to worry about anything in communicating to the Arduino. It just communicated in the background and subscribed to a tag, and it listened to the motor, the motor twist command, and off it went. It just followed.
Yep. He had a couple examples. He was using I2C to communicate between the Raspberry Pi and an Arduino, and it's he's a big fan of God, what is that called now? My mind went blank. Certain environments for like for Python, for OpenCV, and then that way you don't get, if you have other installations of Python or something, they're kind of separated. I guess virtual
Oh,
environment.
Anaconda, you can do that. You
Yeah,
create a,
yeah. Right. So he's a big fan of virtual environments to do
Yeah.
that kind of stuff with. And I think if you're, don't want to, take courses in, vision processing or machine processing or whatever, video processing, I guess. I actually bought one of his earlier courses and stuff just to have it for a reference and to, because if you, kind of like anything, you don't use it and things go away pretty quick.
That's exactly. It was about a year ago since I've been using OpenCV.
Yeah.
I did some testing around with it at work on some of our networked cameras.
Oh, that's cool.
To see if I can, do a similar job that I'm doing with the Cognex cameras. And the answer is yes and no.
Oh, yeah.
And the problem with any camera is lighting. Yeah. If you can't control the light source, it becomes very difficult. Oh, yeah. And industry, it's a lot easier to control a light source than it is in a home environment where you have the sun shining in the windows or shadows on the floor.
Glare. Yeah.
Exactly. Glare.
Yeah. The
I
there's
think
a couple other companies that make pretty good image sensors. I don't know if you've ever heard of OpenMV.
Yep, I do have. I have an original OpenMV board, an MV4, an M4.
Oh, okay. Yeah.
And I played with it as well.
They make a very good system.
The problem is I'm stuck on a way older release of firmware to be able to do anything with it.
Oh, really?
Yeah. In the newer versions of the firmware, I can load it, but the functions don't work.
Oh, yeah. Yep. And then there's it's Chinese. It's the Kendrite A210 processor. You can get basically put together a pretty cheap vision system with one of those. And they even use a similar IDE to the OpenMV stuff. For the most part, some of the things that OpenMV have done, it doesn't, there's not an equivalent function on, the K210 camera systems, but some of the stuff, translates. You can use them back and forth. But yeah, I've got an OpenMV H7. I don't know what the one was before that, but the H7, and now there's an H7 Plus that you can get. It's got a lot more memory on it and does, I guess has more built-in AI functions. But
yeah, there's all. I did see that there's a few different boards coming out.
Yeah.
But there's only so much time in a day as well. And so I've got to get this thing back rolling on the ground. I had homemade encoders on the wheels and I was counting rising and falling edges. But the problem is I only had 64 counts per rotation of a wheel. And when you have a 6-inch diameter wheel, your robot moves quite a bit before you get any sort of reliable count.
Yep.
So I switched out the motors and I put an encoder, I think it's a 200 count encoder on the back of the motor.
Mm-hmm.
And so it's got a 132-to-1 reducer on there. So that'll give me a decent count per wheel revolution now.
Oh yeah. That's David's wheel of a lot of counts is a good thing, huh?
Well, hey, that's why you have interrupts and take care of stuff like that.
Yep. Yeah, some of the motors that, like especially the Chinese ones you get, they may have they're quadrature, but it's like 11 pulses, not a lot of pulses. So if you don't have a high gear ratio, it's kind of like what you experience.
How fast you planning on moving that thing?
Basically, about walking speed at the fastest. It's indoors. You don't want to break anyone's leg as you're racing down the hallway.
And when you slam on the brakes, you're not worried about tilting forward? Do you have enough weight in the back?
Yeah, there's quite a bit of weight on the back caster. It's the battery is almost fully behind the pivot point on the wheels. So
And the battery's low enough. It's not like it's up high, like one
the
of my
battery's
robots.
about 6-8 inches above the center of the wheel.
Yeah.
So I toyed with lowering it down one more level, to be 4 inches closer, but I may do that as well. That's a fairly easy thing to do, to reverse the two platforms.
And are you using lead acid because you're worried of burning down your house like I would be with LiPo batteries, or is some other reason? Because I haven't started using LiPo batteries. They freak me out.
So my phone has LiPo batteries and a few other things do. But the biggest one is cost. So to go equivalent to that battery in LiPo is about double the price. I bought that for $49 on sale. I forget how many 20 amp hours or something. I don't think I can buy a LiPo for that price.
Yeah,
11.1 volts at 20 amp hours. It tends to get pricey.
Not yet. The prices are still working their way down.
10 years from now, I think we'll have lots of options on batteries that'll be safer. I'm looking at one for work, and I keep toying with a battery powered energy storage. So where I would charge the battery at night and discharge the battery during the day. And we're talking about a megawatt hour out of the batteries. So when you look at it, and it's a lot of, you're talking several sea cans full of batteries.
Yeah.
But it's up here. I don't know if you guys have the same thing. We pay what's called global adjustment in Ontario. And so all the solar farms and all the wind farms that generate electricity, they have contracts with the government at about anywhere from 50 to 80 cents a kilowatt hour. Well, that's unaffordable as far as electricity goes. So they pool all that energy up and they figure out a peak charge for the day, and everybody pays essentially an industry on that, based on that rate.
So what do you end up paying per kilowatt hour?
If I do my home electricity, basically at home I'm paying close to 23 cents a kilowatt hour, all in. So that's delivery, maintenance charges, billing charges, everything. 23 cents a kilowatt hour.
Yeah.
In industry, it's closer to 6 or 7 cents.
Yeah.
But it's still, when industry used to be 10 years ago was in the 2 cent range, depending on the time of day and how much you do what's called peak curtailment. Whereas if you think there's a peak coming out, there's 5 peaks during the year. If you think there's going to be a peak hour, you try to shave as much electricity off as you can. And in Ontario, for every megawatt you can shave off, or for every megawatt you can shave off, it's $600,000 a year in electrical savings.
Wow.
So as part of my job, I monitor the energy usage at the mills. And it's something we're really looking into. We did it as one mill for a trial until COVID hit and they put a freeze on it. So we've got until May 1st to decide what we're going to do now with the mills.
Huh. Yeah, I think down here for residential power, I think I pay like 11.4 cents a kilowatt hour, but I think in Dallas it's a much more competitive rate. What do you like, Carl? What are you guys playing in? Do you know?
I haven't paid close attention to it. I wanted to say it's closer to 10 cents, but I don't know.
That's
Okay.
criminal. It's like everything is like more than double up north here.
Wow.
So if I use electricity this time of year, if I use electricity between 7 a.m. and 7 p.m., the official charge rate on my bill is like 21.4 cents a kilowatt hour. If I use it in the off period, so that's the high peak, the high period. If I use it during the low period, I think I'm at 8.4 cents right now. So when you look at the average electricity usage plus all the other charges on the bill, basically I'm at 23 cents roughly average a kilowatt hour.
I just looked at my bill in Arlington, Texas, and I took my total bill divided by the kilowatts, and it's 17 cents per hour.
Yeah.
Well, you know, if you're in Texas, you can go to powertochoose.org, and you've got an apples comparison between all the things, and I got a data sheet on there. And you know, I used to try to sell a little electricity. This thing called I don't know, is a multi-level sort of thing going on there, and of course I'm no good at it, so I didn't do very well. But I learned a lot about electricity and how it gets distributed around, and the fact that who you're paying for your electricity has nothing to do with who generates your electricity.
Yeah.
And once electrons get into the grid, it doesn't matter whether they were generated by coal or wind or solar or whatever. So pay the people you want to pay, you know, to put your stake in the ground. Like, hey, I want to do solar stuff. So we'll pay those people, pay that warehousing company, knowing though that if they can't generate enough stuff, they're going to go buy power from the coal plant. So it's just kind of reality, right? Or do the wind thing, like Green Mountain is a big thing, but they also buy a lot of coal-based power because they're responsible for putting so many kilowatts on the grid for usage. But in general, go to the powertochoose.org, find the cheapest thing, look through the stuff, because there will be all kinds of gotchas in there, like, ooh, you got to sign up for 2 years to get this price. Cool, but if you bug out early, it's expensive to bug out early. You know, those sorts of things. Yeah. And I don't know that I know that's in the state of Texas. I don't know that other states don't have this. I just haven't looked around for it. And every time I go look, and like I changed my electricity company not as quickly as I changed my underwear. So I'm okay with hanging out for a couple of years at a time somewhere. You may not be. There's even a company out there that you give them permission to select the energy company for you, and you may change companies on a monthly basis depending on how it goes, and because they're managing all that for you. You pay a little extra charge so that you're always getting the best rate you can get. And you can say, I believe you can say, yeah, but I want to do green stuff, or I want to do solar stuff, or I want to do wind stuff, and then we'll get you the best rate out of all those things. And some kind of collective bargaining thing or something they do. I don't really know how it works, but I know there's a company out there that'll do it that will change and of course you never lose power, because all you're doing is changing who you're paying, not changing who gets it delivered to you. Because the delivery person, you can't change that. It's not like Green Mountain can drag some new wires down the street and plug them into your house. You're paying a delivery thing. So I didn't mean to go off on all that electric thing there, but hopefully it helps a little bit.
If you buy your power from a solar company,
what
happens at sunset? Your lights go out?
No, your lights do not go out. What happens is there's this thing called ERCOT, which is the Electrical Reliability Council of Texas. I'm just talking about Texas here. It may be different in other states, but what happens is when the sun goes down, that company still says that I'm going to use this many kilowatts of power in a time period over a day, an hour, or whatever it is. And that company is responsible for securing power for you to put onto the grid that gets used, right? Because an electron's an electron, doesn't matter how it gets generated. And so what they do is they will go by, there's the power generating companies, there's the power delivery companies, and there's the people you pay, which are all three different entities. So the ERCOT manages and arranges all that stuff, says, okay, solar people, you said you're going to put 37 kilowatts on the kilowatt hours on the thing this hour. You need to make sure you got that. If you can't do it by solar, arrange for it to be happening whichever means you can, and that generally involves calling a coal plant, or if you're if you're close to a nuclear reactor type of stuff, or some kind of other things to go do that. Yeah. And so,
can I jump in here with a robot question?
Please, please.
Pat, I think the closest we have to a Ross expert here in this group is Chris, or at least the one with the most experience. I know Harold has been working along the same lines, and you add a third party to this. I have a specific question about the Pi as a controller that I wanted to direct to Chris, if I could, which is, I know you have used, can you hear me? I know you have used different microcontrollers on your robots. And so I guess my question is, the robots that use a Pi, was that specifically in order to run ROS, or do you have robots that use a Pi that don't run ROS?
I would say every time I've used the Pi on the robot, it's because I wanted to run ROS. Yes. Robots where I didn't have a need for ROS just because I want to keep it simple, I haven't found the need for a Pi, right? So to me, it comes down to either you need to do ROS or you need to do vision, right? That would be another reason to use the Pi. You may not be using ROS, but maybe you want to do OpenCV and do some other form of computer vision, right? You're gonna need a Pi or a Jetson Nano or something, unless you have an OpenMV, right? I mean, obviously that's the other. But if you want to do OpenCV, that's another reason. Frankly, I have. So I guess I should say I have used a Pi before, just for the purpose of doing vision, and I would say again, the third reason would be, not that I've done it that way, but if you were into LiDAR, let's say you didn't want to put up with all the ROS stuff, but for some reason you wanted to really use LiDAR, you may wanna consider a Pi or something equivalent as well, just because of all the data that needs to be processed. But yeah, in my personal case, it always comes down to either I'm doing something with a camera or a ROS, and so that's when I end up with a Pi.
If you're doing something with a camera, is there also then a secondary microcontroller like Pat was describing, Arduino or something that's actually doing the lower level robot stuff, and the Pi is just doing the camera, or is the Pi doing everything?
I have never done a setup where the Pi was doing everything, right? I mean, I guess everything is already a gray area, right? I mean, you're gonna need a motor driver of some sort, an H-bridge, right? So we're assuming that that's kind of allowed in your definition of doing everything. But I've never sort of done a setup where the Pi was directly, let's say, producing the PWM signal that's going into the H-bridge, right? Or where the Pi was reading all, sensors that produced analog outputs like the sharp IR. I have never done it that way. Again, there's a big gray area, like with all the I2C IO expanders right now. All of a sudden, I mean, you can do a lot of IO with the Pi if you go the route of I2C based IO expanders and so on. So there's, I think, a big gray area between doing everything on the Pi or doing a Pi plus microcontroller, and then it's with I2C based stuff. It makes it a gray area in my opinion. But again, I've always done Pi plus some other microcontrollers.
Yeah, but the stuff that Jason used to do, he used to have a laptop running Linux, and he had it hooked to the Xbox Connect, and he was actually using, God, it wasn't the Ramba base, but it was similar to Ramba, and I think it had its own control board and processor in it. So But yeah, so I guess similar things you could run.
Yeah, I mean, I have a Kabuki that looks like a robot vacuum.
Yeah.
It's a TurtleBot second generation. We were trying a startup a couple years ago. We were trying to create a floor cleaning robot. Didn't get very far with it, but so I have a Kabuki, looks like a robot vacuum, and like I said, it has a, you don't see it, but inside of it is a microcontroller, right? And you talk to it, and so if you add to that a Pi, it's still a sort of a dual processor setup in a way, because you're talking to this microcontroller over some sort of interface.
That's the plan that I had as well, where basically the Arduino is going to say, hey, there's a wall, 6.5 inches away. Are you, you're going towards the wall, or you're going away from the wall? Basically that sort of thing, where the upper level, the Pi, could do the subsumption architecture and decide how to react to that.
Yeah, I mean, if you're doing subsumption, again, putting camera aside, as some of us would argue, you could probably do, well, most of that on an Arduino, depending what kind of Arduino you're using. If it's the old-fashioned Atmel, 8-bit style, it gets a little hard. I managed to get a lot done on those too, but if it's a newer style Arduino, you can get a lot done if your style of programming is subsumption. But then you mentioned Python, right? Okay, so you need something beefier to do the Python part.
Yeah, and then the other thing is troubleshooting tools. You can do a lot with Python and running a window and seeing what's actually happening in real world situations, which is a little tougher on an 8 or 32-bit processor, to try to, and you're running behind it, looking at the screen or checking out what a LED light is doing, or makes it a little bit tougher to get a real-time visual feedback on several sensors.
Yeah, and you mentioned how you liked the sort of communication in ROS, and you didn't really care for sort of some of the other parts. But I guess so I'll throw in that one of the things I do appreciate about ROS is the diagnostic tools that it has, right, for visualizing stuff, especially if you're trying to do navigation. I mean, it's maybe not as important for just lower level motor control or even just teleoperation. There's not that much to diagnose. But if you're trying to do anything more sophisticated with path planning, having a way to visualize all that is really key. And so ROS gives you some of those tools. And so I don't know if you've used those in your work with ROS, but I found those tools like RQT and RViz, quite useful, where you can visualize, if you have even just sonar sensors, right, that, even if you don't have something as sophisticated as a LiDAR, you can sort of set it up so that you have like a visual of, here's my robot, here's what the sensors are picking up at this current moment in time, and, in a fairly real-time fashion, you can have this showing up on a screen. So I think there's potential benefit of ROS.
I agree. There's a lot of good tools that have come with it. Like RViz is one I played around a little bit with, but some of the path planning, the real world modeling, they've got quite a steep learning curve to them.
I know, and I'm still climbing there. So I was going to ask sort of Harold where he is right now, because I'm trying to get back into ROS, and I know, Harold, you mentioned ROS 2. Mm-hmm. I need to look into that because ROS 1 is going to be obsolete soon. So I'm thinking of getting back into fiddling with my LiDAR on my Romy base here. And I just recently installed ROS 2 in a virtual machine so I can figure out what's different about it. But so, Harold, I was going to ask you, so you're not using LiDAR, I think, at least I haven't heard you mention LiDAR.
I'm not using anything very fancy at all. I'm telling you what I'm doing now is I'm still going through the tutorials. This is the second time I've tried to do this. This time it's actually working. The first time I had a lot of problems with it, and I had some issues. I have no idea why I'm not having those problems now. but maybe I learned a few things, and maybe I held my mouth right when I hit the enter key or something, you know. So, but I'm still I'm struggling. I'm trudging down that now because I know more about my hardware and what I think I need to do and what I need to do. And I was trying to capture two things at once. I didn't know what kind of hardware was going to do and how things were all going to work back in June. And I was trying to figure out how to this raw stuff and figure out the hardware and how it all played together at the same time. And I kind of backed off of that and just plugged the hardware together and made them all work one at a time, one step at a time. And now I'm getting a better handle on the ROS too, and the nodes and services. And I'm finding, again, I don't, much like Pat was saying, I'm going to defer to some of his things because he's actually using it real world to move 5-ton machines around and things. Or I don't know if he's using that to do the 5-ton machines, but I'm liking a lot of things, especially when it comes to the architecture, how messages get passed between them, and the fact that I can go look and I can inject things into topics and that kind of stuff to say, hey, go do this thing. And the thing doesn't care where it got the message from, just as long as it's got the right message parameters, the right message picture shape to go into it, it'll act on it the way I want it to act. And so I'm still, you guys may think I'm third in the ROS thing because between you and Pat, I don't know, Chris, you're probably the king. On this thing, but I'm such a distant third. I'm plinking. I'm learning all kinds of new stuff minute by minute. In fact, that's why I've been sitting here being a little quiet here, is I'm going through launch files and some other things there to figure some of that stuff out. And I'm not saying I can't be of help. I'm just don't know how I can be of help at this point. Does that make sense?
Yeah, I mean, there's a lot of hoops to make it jump through. That's the thing. Now, I'm just surprised. So if you're not using LiDAR, are you using a camera, Harold? Are you planning to do vision at some point?
Planning to do vision, yes, sir.
You're planning to do vision, okay.
Which is why I got the Latte Panda, which is running Windows, and I was going to do some machine learning on the edge sort of thing and plug in a USB camera on the thing on a tilt and pan thing for on top of my robot. So that's kind of what I was going with on that. Although LiDAR is cool. In fact, I may stick some of those things on those little things like Carl is those $25 units instead of the ultrasonic rangefinders on the thing. I might do that, use LiDAR in that capacity. But that spinning thing that you've got going on, I'm a ways away from that. You know, that wasn't currently in my plan.
You get there.
Yeah. Eventually, maybe before I die, it'll be fun. But it'll be fun getting there, guys. It'll be fun getting there. Yeah, I've got as I'm talking, not to shut the thing over. I did have a couple of things like Christmas present. That's from sister. Sister also got me this Cooley watch. You can't hardly see it. It's got R2D2 on it. Let's see if I can take it off. I'm wearing it right now because it's an auto winder, and the things about auto winders, if you don't wear them, then they don't wind. So here, I got the head up, right? Got the face up, and she knows I'm a Star Wars fan. So can you see that as an R2D2 watch? Is it too dark? We'll get a little light on the subject.
Too small.
Oh, here, let me.
Oh yeah, the colors are clear.
Let me change over here a second. Overhead, close up. And we'll just pick you up, move you around. It's
nice.
It's an Invicta watch. I don't know how much she really paid for it, but I'm sure she didn't pay the MSRP on it, which is like $1,700. Because my sister doesn't have very much money, so I'm sure she got it at some kind of good deal somewhere. And this is it's pretty nice, And yeah, and I got this. I don't know. I'm going to do something with this. Hello. Well, this was stocking stuffers. So I'm thinking that, I don't know, maybe we could do something funny with that. Anyway, So I don't know. That's about all I got on the thing. But back on this deal, I'm really my ROS 2 fire up now. I've got it on my Latte Panda. I've got it on my lab machine. And I'm going through the tutorials with the end goal of running something on my lab machine and have it connecting to my Latte Panda and being able to do console messages. And so I have, have the ROS network span over the wireless network I have in my house, so that I think I can do extra stuff and debugging and things. At least I think I need to be able to do that in order to get stuff. So for all those visualizers that Chris was talking about, so I can run them on my lab machine and see things without having to have stuff on it. So I don't know if that answered your question at all, Chris, or just said, well, that means I'm further on. Maybe I'm out here by myself.
I just wanted to know if you're doing lab, where you are in your journey with ROS. So I think I get the picture.
You get the picture. And so I still got a ways to go, but I'm really digging the message passing, the way services work, the way actions work, and the way the nodes do what they do in the topics and the messaging queue. I'm really digging how all that works, because as much as I don't get to do this robotic stuff in my day-to-day, I am doing very similar things, how ROS is architected in my day-to-day work for doing message passing and event-driven sorts of things. In fact, a lot of times they're referring to, we're not doing database stuff, we're doing event sourcing. Oh, it means you're storing a bunch of data in a database and then playing it back out to get the state of the thing. Okay, cool, got it. It's not exactly that simple, but there's some high-level concepts that a lot of people are using, and the fact that I get to use some of that knowledge and some of that understanding of that architecture in my hobby, and maybe they can get a little circular thing going on there and make me better in both places, I think is awesome. Yeah.
Cool.
Yeah, that's about all I got, really. I didn't mean to take over the conversation either, but sort of just.
Yeah, I mean, you didn't really take over. I mean, I didn't really have anything else. That just because I'm more like, after all the line following sort of work, that was quite a bit of work, right? I'm trying to figure out what's next. It's either going to be TensorFlow, which I said already I wanted to learn and do line following with a neural net, or back into ROS and get my navigation to work at some point. It's one of those two things I have to figure out where I want to spend my time.
Well, since I'm a Microsoft MVP, kind of my long-term goal here is to be able to train up me some custom vision stuff in the cloud, and inject that model onto my robot, so it can do some machine learning sort of on the edge thing, image detection and stuff. Not TensorFlow. People use TensorFlow. I just never have. But I'm thinking maybe I can use some of this custom vision to get done what I want to get done and play with, and explore it a little bit, see where I go with it. You may end up nowhere, but I figure I'll learn something along the way, so it's probably the journey's probably worth it, regardless. So, yeah.
Cool. All right. Let's see. So swinging around, Doug, I think you're muted. Doug Paradis. So
I wanted to update the prizes that are done through Printful. Dave, your cup is on its way. It's fulfilled. So that means it's in the mail. So you can see it in the next day or two. This was my prize, which was a hat. I don't know if you can, I'm trying to figure out how you can see it. Carl had it on the prize list. It's probably a better picture, but it came out really well. So this is an official khaki DPRG hat, as opposed to a blue official DPRG hat. So anyway, just wanted to update Dave. He had a prize coming, and it's in the mail, from my understanding. It's been fulfilled by the company. I don't know if Chris has got his, but
Chris is not.
No, it's coming on the 4th.
Okay, cool.
Good. Okay, it's got a date. That's good. Because yours
Okay.
and Jesse's are in that state. But I still have to make it to Makerspace for the T-shirts and the stickers and the other. It's a little slow here right now to get things done, but
yeah.
they're in process. They're not in the mail.
Yep.
Is the makerspace surviving? I mean, I'm sure members have dropped off because you can't really go there.
I don't know. All I can say is, they still do DMS talk periodically. So.
Oh, they do. Okay.
Yeah. So I mean, I can't really tell. So there's people down there.
Huh.
I know that the lab that was in over there in off 75 in over Plano. Yeah, Plano has moved down to Richardson. They've actually expanded their space and moved into new space. So I guess
they
okay.
They got a deal with the city, so that was
okay.
They got a sweet deal with the city, and so it'll be interesting how that develops. I know that they're offering at, I think, until the end of the year, maybe it's over, but I think it's to the end of the year, reduced membership prices, but they're going to be a little bit expensive, I think, for what they have. Now maybe eventually they'll have enough stuff to make it worthwhile. It's slightly different from the Dallas Makerspace.
It is. I just know some of those guys over there on the board, Tommy and a few of those other folks that run around and they. So I just kind of follow them. I know druthers one way or another.
Yeah, we actually had a meeting over there once because it's a very welcoming group of people. I mean, to me it would be like, hey, that would be makes much more sense for me because of where I live to be a member of the lab than it would be the DMS.
Yeah.
But right now, DMS has got more of the stuff that I would want to do.
They certainly have a lot of stuff. There's no doubt about that.
And more expensive toys.
Yeah.
Mm-hmm.
There's another one opening up in the, or it's open now, I guess, in the Frontier Flight Museum. I've heard it's pretty thorough.
Really?
Oh yeah.
I hadn't heard anything about
that. I don't know the name of it, but I know somebody that's it's close to where he lives, so he's pretty much migrated from the DMA down to that one. But then I know so many libraries around town, they're opening up with 3D printers and laser cutters, and so there's a lot of competition for maker space kind of.
Yeah, but that's why I'm saying is but DMS they've been around long enough that they've got pretty much, and they made a good decision a while back. They made a decision that, yes, you may have a table saw, but we got a table saw. You know what I mean?
One of those
they got the cabinet grade stuff.
Cabinet grade, saw stop kind of thing. Yeah, there's no doubt about that. That is some serious quality equipment that they have.
Yeah,
it's not going to do 34 2x6x10s in an 8-hour shift, but it's going to do some nice cabinet grade stuff.
Yeah. I'm just saying is, that everything they have, welding equipment, powder coat, they have a powder coat oven, they have, forging, they have induction forges, they have
pottery, ham radio,
I mean, jewelry, I mean, stained glass, I mean, they got, and all of the, all of the stuff that you would, if you were doing it yourself, you would say, damn, I wish I had the money to buy the real good stuff. They got it.
Yeah.
And
I think about POS milling machine. You have probably $30,000 CNC table.
Yeah.
Yep.
Right. Well, let's see.
Anyway.
So we've bounced around a lot, and I've totally lost track of who has and hasn't described their projects. Is there anybody we've missed? Anyone?
I do have a few things that
All right.
I'm just playing with, okay? I don't know how to show this on this, and I probably should have done some prep. But, okay, this is, the Polo motors will do the same thing, but this happens to be the one I'm messing with. This is the DF Robot, a yellow cheapo motor, but it's the one that has the encoder on it, and it's about $8. And this is a wheel that David Ackley turned me on to, which is also from DF Robot, which is really nice. So I really want to use these. Now, the problem with all of these things is this is not really good design to do this. And the reason is because you can see that the wheel will wobble. And that doesn't get better over time, by the way. So what I've been thinking about,
Even Loctite won't fix it.
yeah, even well, it'll fix it, but you won't wobble, but that's it. There's a 3mm screw hole here in the end, and it feeds through the wheel, as you can see there. So I just picked up some small bearings, and what I'm going to do is I'm going to make a 4mm shaft. Well, it'll start with a 3mm screw. If you can think about it, it would go out here, and then it will turn into a 4mm shaft. Then, so what you'll do is you'll put the motor on it. Then you'll take your little extension, which is a 4mm shaft with a 3mm screw in it, and screw it in. And then I'm making something like, let's see, a pillar block. And let's see, is it on that page? No, it's not on that page. That's why you can't see it. Extending my platform base. So instead of the wheel hanging off the edge of the platform, what will really be there is it'll be the platform will wrap around the wheel, and this is actually not the wheel. This is a hole for the wheel. So the motor will be mounted in here, and the pillar block will go here, and it'll have one of these little, very small bearings on the end of it. And that's one of the things I'm playing with to try to take the slop out of this system. So anyway, that's a project that it's not a big project, but it's a little project. And oh, by the way, do you notice that Ron's not on today?
Yeah.
Turns out he thought he had the flu, but he said, well, maybe it's COVID. So he went down and got tested for COVID. It's not COVID. It turns out he has, I don't remember the name of the disease, but it's essentially a irritation around the heart. So he's actually in the hospital right now.
Oh, he is. Oh.
He is.
Wow.
This is Ron. Ron Grant.
Yeah, and he's hoping his message. I pinged him on something totally different, and he said, yeah, that's okay. But he was in the hospital, and he was hoping to get out today or tomorrow, but just so that everybody knows why he's not here. But I wanted to show another project. Here's my transistor tester now. Here it is. It's now got a nice little case, and so it's all cool, and it's labeled. This is actually a nice little tester. This is the step above the $5 one. It actually has oh yeah, you got it. That's not. Well, no,
that's the $5 one.
Yeah. This one has has an encoder switch here, which allows it to it has a frequency generator and it also has a frequency meter built into this, and it can do PWM output. So that's kind of cool. So like you could, in theory, test something.
And how much was that?
It's depending on where you get it. You know, if you get it from AliExpress, it's $12. If you get it from Amazon, it's about 25. Okay, but this is the latest, or the one you held up, Chris, was the guy that designed all of this. That was his first version. Okay, and this is like his upgraded version. It's pretty cool.
Is that a color display?
Huh?
Is it color display or monochrome?
I know some versions come with a color display. I don't know. I think this one is just green.
Okay.
Now on Amazon, what would it be called?
Oh, okay. That is a good
Yellow
question. It's something like, give me a second. It does have a very distinctive name.
Like long, I mean, you said it's doing PWM output as well?
It has that ability. Yeah. It's called a GM328. Now, that, like I say, there's all sorts of vendors all over the place, but basically you're looking for a GM328 component tester. And like I say, it's all,
Right, it's like
you can
series.
many vendors, many different prices. It's a kit, so you do have to solder it together. I mean, I don't know, you might be able to get it put together too, but the one I got was a kit. It wasn't hard, and it's just, you know, it's through hole soldering. There are some of the older kits didn't. There are two surface mount parts, and the older kits didn't have them soldered on the board, and they got some bad ratings because for some reason everybody soldered in one of the pieces backwards, and so they now solder them on for you, and so all you're doing is through hole soldering. It's a piece of cake to put together. Just, you know, one piece at a time. So anyway, it's kind of cool, and I feel that it's more protected.
Put it up again. Let's see let's see it again. Okay, is that a dip socket kind of thing there?
Yeah, it's what do they call those? Yeah, it's one of those green sockets where you lift the lever and it pops out.
Yep. Okay.
Yeah, and I have mine set up for it has a place for a 9-volt battery like Chris's, but I just set since I wouldn't use it very often, and I have it sitting with my multimeters. I just use a 9-volt power supply that I always have plugged in the desk anyway. Yeah, it's really cool. I mean, I think Chris's will do all the measurements. I mean, it'll do capacitors, it'll do inductors, it'll actually do some of the temperature or humidity sensors, you know, those DSHs, I don't remember the numbers, and several other little weird things that you wouldn't expect. It even I don't know what the ability to source current is, but it even acts as a small voltage supply that you can adjustable voltage supply. But I don't know. Like I said, I don't know what it can source. And I've looked at it on the oscilloscope, and very accurate. Surprising. I mean, well, not so much because the kit has a crystal in it. So it's a crystal-based oscillator. So it's very accurate on the frequency output and the receiving frequency. Oh, it's a nice little gizmo if you're going to be screwing around with electronics. You know, like I said, I don't know how much. I don't know. Like the one that Chris has looks really nice too, and that one might be perfectly adequate. I don't. You can do inductors and capacitors on that one. Yeah, yeah. So,
Yep.
I had a nice capacitor meter, but I didn't have an induction meter. And
The only thing I found with mine is it doesn't do too well with really, once you get down into the picofarads,
yeah,
like double-digit picofarads, I don't remember where it sort of stops working, but it doesn't really go down into real small capacitors, you know.
well, it might become more of a guess down there, but I know that on this one you do a calibration routine, and it does seem to do it. It might push it a little bit further than yours, Chris, but you know, they all have updatable software if you want to. Yeah.
Here's an old ancient one I have from way back when.
Yeah.
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 Pretty good job.
Yeah. Like I say, you know, it's all based on Atmel 328. So at Megger 328. So kind of cool. So that was one little project that I put together after Christmas. And
there's a lot more soldering and 3D printing than Dave Ackley's.
Yeah.
Oh, well, the nice thing is they didn't have to design the case. It's the Thingiverse deal. You know, that's really cool. I mean, the guy did a good. You know how Thingiverse is really kind of iffy. Sometimes you get a great one. I mean, absolutely great. And then sometimes you get something that's like, holy mackerel, what was this guy on? You know, so, but this one was a good one. I don't fault the kit. You know, pretty cool.
All right, cool. Let's see. So swinging around, anybody else?
Well, I also really look forward to giving Dave Ackley's method of motor control a spin. I want to see, play with that. That was a good idea. And I did have a question to you, Carl.
All right.
Give me a second. A couple of weeks ago, you talked about how your robot was using two sensors to balance the line. All right. So you mentioned there was a PWM on it. So what is the PWM? Is it trying to drive both lines to zero, or is it trying to? I mean,
sorry.
Okay, you remember you were talking about you had a forward backward sensor, and
yes.
You said that you had a PWM driving these two to the same.
Oh, I had a PID loop.
PID loop.
Yeah.
I'm sorry. I've got PWM on the brain. PID loop driving it to the same center. So was it looking at the difference between these two? And that was not. There had to be something that was driving it to zero also.
So yeah, if you hold that up for a second, because that's a good drawing, and you can get that much faster than I can show it. I'm going to pin that over on the recording while it's going here, so I'll explain your drawing. That's an excellent sketch, and the basic concept is So hold up a little higher if you could there. Okay, Doug. So like look at the straight line there, and and you'll see where the two lines cross, the line sensors cross, and there's a dot in the middle.
Right.
So what my algorithm would do is pretty simple. It would say, first of all, it assumes that the center of the sensor from left to right is the where you want to be.
Right, that's
Okay.
the reference point.
Yeah. So it would take the error of the front line sensor, whether it's to the right of the line or the left of the line, it would take that error, and then it would take the error for the bottom line, whether it's to the right or the left, and it would just, we'll see you, Pat. Thanks for joining. Hope to see you next week.
Thanks, guys. It's getting late here.
Yeah.
Yeah.
So it would take those errors on, like, how far is the front sensor from the center of the line, and how far is the back sensor from the center of the line. So then it would take, like, think of it like the sideways motion is common mode rejection ratio, right? So if you take the average of the error from center, so like let's say the one dot is off to the right by 5 and the other dot is off to the right by 7. Well, the average is that they're off to the right by 6.
Right.
So that means the sideways motion of the robot, the lateral translation, should be 6 in the other direction. All right.
Okay.
And now conversely, with that direction, like if the front is 5 and the back is 6, that means that it's rotated. It's like veering away towards the right. So then that means because the difference from 5 to 6 is 1, the difference of the two is 1. So it would calculate the angle that corresponds to that difference and try and rotate it. So just with those two line sensors, you would have a translation error and a rotation error. So what the robot that I did, all it would try to do is work with, it would, like in a simple way, it would just have two line sensors. And as long as you could keep it going more or less within range of those two sensors, it would take and try and correct the sideways translation and the rotation, and it would just move forward.
Okay.
And adjust the speed.
Okay, I think I understand a little bit better. Thanks.
Sure. Yeah, and then it just got complicated because it would detect that when it got too far out of range, it knew there was like an intersection, or it knew that it was time to change orientation of the robot. So then it would all of a sudden, instead of using the front and back sensors as front and back, it would treat the left and right sensors as front and back. So that's where it got a bit confusing.
Okay.
All right, so swinging around the table then, let's see, have we missed anybody?
Been pretty much working on the same thing I was last week, so I don't have anything new to show. I've made some decisions on, the pieces of metal that I'm using, but other than that, it's kind of like I want my cake and eat it too with the metal stock. So, I have to really, it's a tough decision. It's like, okay, can I part with this? All right, I will. And working on just getting familiar with Bridgeport CNC codes, because they're different than the Gerbil stuff. They're a lot more sophisticated. You can have I forget what it is. If it's a G86 that will go to an XY position and actually do a drill pecking routine, all with one line of code to whatever depth you tell it to at whatever feed rate you want it to feed in the hole. And so it's a lot more sophisticated than the Gerbil stuff, but I only have one machine. It's really old and I don't want to screw it up. So I've got to do all these tests before I actually run the part. So I've got to make sure the tool holder clears the top of the part, or the drill is long enough, and all that kind of stuff. So it takes me forever to make the program to run the part, but just a few minutes to actually run it. So, because I don't want to break anything. So.
Yeah, that's well,
That's cool.
Dave Anderson had an interesting observation about working with metal. He said that the more you work with it, the more valuable the part becomes, and the more you'll do to try to save that part to keep it from, being scrapped. So I understand. Yeah.
Yeah, I actually ran some sample programs on the little mini mill.
Yeah.
And there's something going on with that. It's the Y direction is a little off in scale. It's I did like a little 2-inch by 2-inch outline, and it's less than 2 inches in the Y direction. So I was like, oh my God, what did I do? I must have screwed something up. I haven't gone over it mechanically to try to figure out if it's got a at least loose coupler on like the lead screw or something, but I'm pretty certain it'll work in the Bridgeport, so I'm not certain what's going on with this other machine. So it's just one of those things. It's like, wait a minute, it's not right.
Yeah.
So
I have a quick question for the group, a recommendation I'm looking for. I've been wanting, since we're talking about the function and the part tester, that reminded me, I've been thinking about getting an oscilloscope. I have a real old 30 megahertz, analog scope, and I've been wanting to get something more sophisticated. And so if someone has done a purchase recently, I'd look for a recommendation. I'm trying to figure out, should I get an actual, 2-channel or something digital scope? I mean, low end kind of type, Rigel or whatever the brands are, or should I get one of those USB based doohickeys that attach? Yeah, a USB based doohickeys that attaches to your computer and with the SIGROC software or something like that. That's what I'm trying to decide. Standalone scope and which one versus USB based doohickey.
Yeah.
How much you want to spend?
What's that? What do you got there, Carl?
How much you want to spend?
Let's say if it's a USB based doohickey, I mean, I don't want to spend more than $150.
Yeah.
All right. And are you okay? And you're not looking for super high bandwidth, right?
I'd say you want at least 100 megahertz bandwidth, right?
Yeah.
Well, that's not super. Okay. And do you want all those fancy signal decoding and?
Well, the software will do that. SIGROC is the software I use with my $10 logic analyzer. It'll do a lot of good decoding.
Yeah.
But the gadget I have now is just logic, right? I need analog inputs. I need scope type functionality.
You need mixed signal where you have like a bunch of digital and some analog, or are you okay with just a good analog scope, 2 4 channels?
I'm just okay with good analog because I'm already covered on the digital, but my digital gadget is very slow. So maybe actually I need faster digital, so maybe mixed signal with faster digital.
I'm going to put a link in the thing in just a moment or two, but I know Doug was talking about Rigel. But for under 150, you're kind of limited there. But
yeah, but I guess under 250, you've got a lot more choices, right?
Yeah.
Kind of the range. Doug, what's the bandwidth on yours?
Okay, with the Rangels, you can go a couple of different ways with the Rangels. I bought the 50 megahertz, and then there's basically a hack that everybody knows that'll take it up to 100 megahertz. So it's because the 100 megahertz and the 50 megahertz scope are exactly the same, and it's 4 channels. Now I don't often use 4 channels, but occasionally I've found at least 3 to be pretty much fun. And I want to say, I'm trying to figure out, I see one here on Amazon. let's see, this is the 52.
So what model do you have, or is it like a discontinued model?
Oh, that's what I'm trying to figure out. It's a DS 1054 is the one I have. So,
Carl, what was it you held up a minute ago?
This one is I sold this old Bell and Howell thing that I assembled in high school and fixed in college. I sold it at garage scale for $40. Somebody paid for it, and then I bought this for 170. It's obsolete, but this brand, it's really funny. The software that comes with it, when I first fired it up, I could swear they lifted the software from the Techscope that I used back at TI in the 80s. So it's really pretty capable, and it's a nicely done little scope, and like it's 100 megasamples a second, 40 megahertz bandwidth. I just put a link in the Slack for a newer version, like for $78. It comes with, I think you can get them with a couple channels plus a 16-channel logic analyzer. I think this is the one that we got for as a graduation gift for
Jack.
And the only concern I have is is that the software that I have for my old one, it doesn't seem to run on Windows 10 without like violating security policies. So it ran fine on Windows 7, and I just haven't figured out yet the latest driver. So I don't know if they've solved that, if the latest versions of these are Windows 10 compliant.
But there's the SIGROC. I mean, you're not stuck with the software that maybe comes with that, right? So SIGROC is probably compatible with that gadget.
They do have SIGROC drivers, and I know that we tried. Here's a higher speed version of the one I just put in there, and we tried the SIGROC drivers with Jack's stuff, but I can't remember if we were stuck because he was on a Macintosh at the time, or the driver compatibility. I forget exactly what the issue was. I think this is a Handtech version of the Rigol. I just put a link in for that one too.
I want to say there are other brands than Wrangle that have good reputations and are cheaper, but I don't know if I got a deal on it or what, but I remember that I went with this one.
I know I don't own one, but I've done a bunch of research because I do want to own one. And the Rigol, when I said, hey, I need a good entry-level scope, and I just kind of Google or bingle around with that.
Yeah.
And the Rigol brand is mentioned almost, not exclusively, but all the time, especially 50 megahertz to 100 megahertz hack that's going on there. And yeah, they all know about it and that kinds of things. And so they mentioned all they say it seems to be the way to go, for things that I want to do,
It's hard to beat a good bench scope that doesn't require a laptop and drivers and all that other fiddlery. It's really hard to beat that with physical knobs. But if you just want something to carry around in your backpack, you're going to use it like once a month or every other month, and 8-bit digitizing is good enough. I mean, it's hard to. I'd love to upgrade this, but there's no reason to.
Oh, you've got an upgrade coming, my friend.
I do. Yeah, that's right. Oh yeah, so we should pull that up. No talk of oscilloscopes would be done without this. We'll put this link in. Harold and I are on a quest for this.
Yeah.
Very narrow.
What are you doing?
That doesn't fit the less than $150.
Yeah, I think I got the one for $350, but I'm pretty happy with it. I think it's like a one-time investment.
Yeah, and I would agree with it's a time investment. It's $350, I guess. At least that's the price on Amazon right now.
Okay.
But I will say this. Oh, and then one nice feature it has is, you know, you can take screenshots, and I think you can get CSV files of the data. You know, you can, and it all works. You know what I mean? I had no problem getting it all out of the thing.
Okay, here's one for you, Chris. So this is what Harold and I pre-ordered on Kickstarter. They're running like a year late, but I have one of these smaller ones. But basically, these are a really cool little concept in a way. It's basically a oscilloscope DMM thing, but it uses your phone as the display. So you can just carry this or whip this thing out, and it's an oscilloscope or a DMM, or you can even do current measuring. And then the newer version, what you can do is you can gang up to 4 of them and turn it into a 4-channel oscilloscope if you have a big enough phone display. So it senses the signals, digitizes it, and then converts it over BLE so that you can go watch it on your phone's display.
Interesting.
Carl, the device you held up looked like it had 3 B and C connectors on the end. Is that a dual channel with a trigger?
Yeah, so this particular one, and I think the newer versions of it, like I put in the Slack, are the same way. It has channel 1, channel 2, and an external trigger. And it has a grounding connector and a probe calibration input as well. And it can handle a pretty wide range, you know, with the 10X probes they give you. It can handle a pretty wide range of voltages. And I mean, they must do a decent job of scaling, because whenever I get from the 10 volts per division down to the millivolts per division, you can hear the relays clicking in there. And I mean, they do a nice job of getting the signal within range. So, I mean, for the little stuff that we do with the Arduinos and with these robots, I don't think I need anything faster than this. And 2 channels. Yeah, I mean, Ray, you got the same, but that's a 1-channel jobber, right?
Yep.
And plus it's a storage scope, so you can trigger it and capture it on the display, and then just get it out of the way when you're done.
This one you can easily fit in your top pocket.
Even more so. Yeah.
You know, the first thing, if you don't have one, is those little it's saline clones. I'm not sure if I'm saying that right, but they're the little logic analyzers that cost,
I have that.
I mean, I think 8 channels, and they're, depending on where you buy them, $5 to $15.
Yep.
That is a fantastic little piece of gear.
Agreed. I have it. It's a little. I wish it was a little faster, maybe in some situations. But you know, if you have some real fast SPI going on, SPI, you know, you know, sometimes you need something a little faster. But yeah, that's definitely worth every penny.
Yep, that would be, if somebody was just starting out and didn't have anything, I'd say that's the first thing you get.
I will say I found that on Windows, it's been very unreliable for me in getting the full speed out of it that it's capable of, versus running the software on a Linux setup. I haven't had that issue, right? There's something with the drivers on Windows, or whether, I think I've tried it on more than one laptop, where sometimes I get the full acquisition speed, sometimes I don't. You know, there's something going on. Again, I haven't seen that same issue on just running Linux natively on a laptop, but that's the only issue I've had so far with it.
I've never noticed that, Chris, on mine. I actually have 2 of them, because they were so cheap, and you know, it's like one day I couldn't find it. I just ordered another one, and then I found it, so now I got two. You know, but I always probably use it right here in front of this desk. So I'm probably using a desktop all the time that I use it, because my work table is within arm reach. So I just, you know, it's all USB, so there's just a little cable going off to it. So I don't know, maybe on a laptop it might be different. But both the Wrangle and this have, you know, a set of protocols that you can load into them. So the Wrangle has that too, but if you're using, and you can get a Wrangle that has a logic analyzer in it, but I wouldn't pay for it because for our work, the $5 and $10 ones, they do great. I mean, I can't see doing it, but
And the
I
value
think,
is really coming from the software, though. That SIGROG open, you know, that free software with all the different protocol decoders, where you can stack, you know, SD card on top of SPI. I mean, right? You can do multiple layers, and I haven't even used all the bells and whistles. I was using it for CAN and CAN FD, and you know, it's just beautiful.
yeah, I was using it. We had I don't know if you ever met one of our members named Omar, and he was having a hard time getting his mind wrapped around I²C, and this just, you know, I mean, this, you know, it just makes it so easy to understand. Yeah, I think I followed Dave Ackley recommended another tester for CAN, I believe, and I think I picked it up, but I haven't really done much with CAN, though I do think that's the best protocol to use if you can do it. Yeah.
We'll see you,
Carl,
Doug.
did that device come with the probes?
Yeah, I mean, and I got it like 8 years ago, that particular one. It was $180 with it was either 2 or 4 probes, and then I got extra probes. But I mean, you can see.
On this ancient electronics here, a pair of probes themselves are $150. So that's why I was asking.
Well, you can find the Handtech, and I've been pleased with the probes. I mean, here's the deal. I used to do laser rangefinders for military vehicles, right? So I worked with relatively expensive, good grade Tektronix stuff back in the day. And from what I can tell, this stuff it's not the 12-bit or 14-bit digitization that we had. And you know, it's not going to get the multi-megahertz edge quality that you would with the other ones, but it's still pretty good, even for $20 probes.
Are they adjustable probes?
They are.
Can you adjust the capacitance?
Yeah. They have. I mean, they got a 10x switch on them, and they also have the compensation. Like I said, the thing had built into it. It had the little kilohertz reference source, so you could just make sure you get a square edge for the capacitance on them. And it's got the same. I mean, I think they knocked off the patent, or it expired, or somebody has to have patented these, but. And they have little color bands, so you can color your probes to match the
input. Yeah.
You know, red or green. Well, actually, I use the color on the display. So.
Yeah, and the Wrangle comes with 4 probes too. You know, very similar to those. And
I think they're a commodity these days.
Yeah.
Yeah, do you think the Tektronix may be a little more rugged? Take a little more.
Actually, I've had one probe fail me on all of the stuff I've done, and it was a Tektronix probe.
Oh, it was, yeah.
Yeah, it was, and
I wouldn't worry about these.
So expensive to get them repaired that it's just, just throw it in the corner,
Yeah.
you know.
I haven't broken any of these in 8 years, and even if I did, okay, it's 15 or 20 bucks. So
yeah, I agree with Carl. At least at the 100 megahertz range. I don't know.
It's great when you don't have to have equipment that's traceable to the National Bureau of Standards, right? As you look around at our great labs, there's nobody with the calibration nearby, and that's just fine. It's close enough.
Did I get this Tektronix 475 I have here, which is actually borrowed from work? But I remember a time when that was the small portable scope, and you used to see guys running through the airport carrying those on their way to some gig.
I had to carry one around.
Who was running through the airport?
Yeah. In fact, that was I got one that had a chance to get one of them, and I jumped on that with a stick, and that was my workhorse for years. But it was just so big, you know. And I find, and it didn't have storage, and that's very important.
What had oh, you got the cart and everything. Oh my goodness.
My cart's now holding welders.
All right, guys. Hey, it's getting late, but I think Mr. David Anderson had his hand up some time back, and
I haven't done anything, but I've been thinking, and you know the navigation while pirouetting that I showed a few weeks ago. The downside of that is that it can't avoid obstacles. So I've been thinking about how to solve that problem. And my first thought was that I was just going to build this 360-degree buffer, and I'd go in and select which sensors to be active. But as I thought about it more, I've decided that that's actually more trouble than I need to go to. All I need to do is filter out basically detections that are not in the direction that the robot is going, which I think I can do fairly easily. So that's my next step. I want to be able to set the thing down and have it move away while spinning and stand in front of it and have it navigate around me.
That's awesome.
So basically that means I have done nothing.
Hey, you've been busy thinking.
Do you guys remember Pogo Possum?
No.
Anybody here remember Pogo Possum? Pogo Possum says, sometimes I sit and think, and sometimes I just sit.
Very nice.
Well, guys, shall we meet again next year?
That sounds good. Yeah. It's been quite a wide-ranging discussion.
I do have one challenge for everybody. Vote.
Vote.
If you're a member of DPRG, please vote. Yeah, I just sent that out sometime last 48 hours or so. So make sure.
Vote us out, vote us in, but we gotta according to our club rules, right? Our 501c formal legal binding stuff, we need some kind of quorum to vote.
Yeah, and then on the Saturday meeting, that's the annual meeting. So Carl, you probably want to MC that with slightly different. I don't know.
I don't know. I
Can
think
I
the
vote?
vote's rigged.
Huh?
I think the vote's
Can I
rigged.
vote if I haven't? Can I vote if I hadn't paid my dues in years? Decades, really.
Well, actually, you have to be on the list, David, on the card carrying list.
I think you can vote all you want. It's a question of whether the Supreme Court will allow the vote or not. So.
Oh yeah.
Oh yeah, there you go.
So.
Well,
I don't know with Jesus, what's his name? He usually counts the votes.
Ron said we might have to.
No, that's how I got with. That's what I was talking to Ron about, and he said yes, he expected to be able to do it.
Okay.
So I don't know how serious this issue is. I mean, it sounded serious to me. You know, something around your heart.
Going to hospital nowadays is scary.
So
Usually when you show up to the hospital, to the doctor, the doctor, I'm not feeling real good. Oh, no, you're going, we called you an ambulance. You're not going home. That's a bad thing. That's never a good thing. Right.
Yeah, exactly. And because of my wife's cancer situation, we've done a lot of telemedical things. They're not the same, dude. The guy can't pick up on a lot of things if you're not there. But anyway, I guess it's adios. I'll see you
Yeah.
guys. All
Have a
right.
good New Year's celebration. We will see you next week.
Yep. Same to you.
Hope next year is better than this one.
There you go.
Amen.
It's bound to
See you on
be.
the other side, guys.
Take care. Good night.
Take care.
Bye. Good night.
Good night, everybody.